So good morning, everyone. We are in Miami time now, so let's start. My name is Ahmed, part of Zak World of Façades organizing team. I'll quickly introduce the event to those who are attending it for the first time. So we've been organizing the Zak World of Façades conference series since 2012. This is edition number 183. We had edition 182 today in another part of the world, in Tashkent, Uzbekistan. So we had another team over there which was executing that event. Uh, it's a gem of a country in Central Asia. Lots of construction activity happening over there. It's not something everyone can say that there's lots happening, but Uzbekistan is one of the countries where there's a phenomenal pipeline of projects, a lot of complex facades coming up. Of course, barring the Middle East. The Middle East is in another league now. So we had our first event in Uzbekistan, so that's country number 45 for us. And here we are in Miami for our second Miami edition. We had our first one last year, same time at the Four Seasons. Yeah, so we've been doing these events globally across several countries, from New Zealand up until Canada. The way facades are designed, engineered, installed in all these countries are very different. In some places, it's about cost control, value engineering. In some places, it's about carbon reduction. Most of Europe is adaptive reuse. They don't build new. It's 90% adaptive reuse projects where they use the existing structure and reclad the facade. So we adapt our programs to meet the requirements of that respective region. For example, here, Florida, we are in a boom of new build, but the same cannot be said about other places in the US. We were in Boston and Seattle last month, a completely different story. Miami reminds me of Dubai, which is where I am from. Lots of branded residences. You've got Bugatti residences, Bulgari residences, Mercedes-Benz. Miami and Dubai are the only two locations in the world which have these kind of branded residences. So interesting time for these cities, and I think we need to cash in on the same. So, as I said, every event is different. I think today's program is also a reflection of the same. Our conference director, Susan, has put across a very good agenda. Of course, we try to keep it as different as we can from the last edition. But yeah, I hope you enjoy the storytelling of our partners, of our speakers today. These events are thanks to our event partners. I'll start off by introducing all of them. We've got 21 of them. I'll try to go quickly. All of them have a booth outside, a tabletop outside. Please meet with them in the networking breaks when you can. Aluminum and glass solutions. So they are based in Florida. So they do aluminum and glass restoration services. Becker's is one of the global leaders in coil coating solutions. Dry Design, a Kingspan company. They've got rain screen cladding solutions. LMX got rain screen cladding as well as building integrated photovoltaic solutions. ES Group, they are part of a larger group. They do contracting, they do glass processing, they do metal fabrication. One of the leading players here, don't need to introduce them much. FlexBrick is an innovative company out of Spain. They have a very nice fixing system which can be used as a second skin, as a shading device. They've got a lot of innovative references. I know car parking garages are big here in Miami. I think their solution is one alternative to beautify your car parks than your conventional aluminum screens. Kale is from Turkey. Kale has ceramic cladding solutions. They're one of the global leaders in ceramic cladding solutions. Convenor, again, needs no introduction, one of the leaders in aluminum door, window, curtain wall systems. Momentive, again, part of the GE group, one of the global leaders in sealing and bonding solutions. MSI Surfaces is also an integrator of ceramic and rain screen cladding solutions. Parallel Architectural, again, an American company. They've got aluminum cladding solutions. Porcelanosa Facade, part of the Porcelanosa group, global leaders in ceramic and porcelain cladding solutions. Started off with the sanitary ware solutions, and now they have fabulous styles which they engineer for the external facade. PPG, again, global leaders in liquid coating solutions. Q Railing is a German manufacturer, so they have railing solutions, both aluminium, stainless steel, all kinds of different railing solutions. Reyes Aluminum from Belgium, one of the global leaders in aluminium door, window, and curtain wall systems. Saflex and Vensiva are the products from Eastman. So these are laminated glass interlayers. I know this is a hurricane zone, so you need to laminate your glasses, and they're one of the leading solution providers for the same. Safety First is a fire-rated framing and glazing solutions provider. SEDAC from Germany, global leaders in jumbo glass solutions. They can go up to 22 or 23 meters, if I'm not mistaken, single piece of glass behind the glass of many Apple stores globally. Sherwin-Williams, again, a global leader in liquid coating PVDF solutions. STI Firestop, again, a global leader in passive fire protection for ventilated facades and curtain wall. Stowe from Germany, they've got glass rain screen solutions, they've got a stucco-based cladding and a lot of other rain screen cladding solutions. And of course, our next event is next week, actually. That's our French event in Montreal, Canada. We have Maxime, our host for the event. He's one of the leading architects out of Canada. He's going to be chairing the event next week. And of course, Montreal is, again, very unique. It's one of the faster growing cities in Canada. And that's going to be our second edition in Montreal. And of course, our other North American events, we return back to Chicago. We're going back to New York City, which is the largest in our series of events in North America. Close to 750 delegates attend the event. It's a 3-track event. We are debuting in Atlanta for the first time. And of course, we return with, we end the year with Toronto, which is our 3rd time over there. So these are the events we are doing in North America. And as I said, every event is different. We like to curate bespoke content for all our events. And we'd like to do these events in a way which is very premium. So that's why we try to choose the best of locations. We try to put up these fancy screens, just not project them on a projector, because I still believe that facades are the most important part of the building. If your facade is good, you can generate a lot of revenue out of it. I know a lot of people focus on interiors, but I think a good facade is equally important as a good interior. And you know, facades are stylish, so we'd also want to execute stylish events. So that's something which we've always been very particular in doing so with all our events globally. Okay, we've recorded today's event. So we've got, we'll share a YouTube link with all of you once we have permission from all the speakers, if you're okay to share their presentations. Another sad thing is this venue is unfortunately going to be demolished. I believe we are the last event here at this venue. They are demolishing this and building a 60-70 story tower, which is actually going to be featured on the program right at the end of the day. This is a KPF designed building, along with the developer Swire from Hong Kong are going to be on that panel talking about the future of this property. And it's going to be moderated by Lisa Ramig of Eckersley O'Callaghan. She had an excellent presentation last year for those who witnessed the same. So please stay back until the end of the day. It's a lovely panel between the developer Swire Properties, the architect KPF, and the facade engineer Eckersley O'Callaghan, Lisa Ramig. That's it from me. I'd like to call upon our event host and convener, Jawad Ahmed. He is the founder of JAPE, Jawad Ahmed PE, which is JAPE. He's going to be hosting today's event, a great friend of ours. And over to you, Jawad. A little overdressed from Miami. I'm a Thai guy, but I saw people in shorts and T-shirts yesterday. I thought I'll underdress, but you beat me to it. Thank you so much.
Good morning, everybody. Thank you, Ahmed, for the amazing introduction. Again, welcome to the Zak World of Façades. This is our second event here in this beautiful city of Miami. I'm honored to be your host for today's event. And again, I'm Javad and the founder and CEO of JAPE. And first, again, thank you to Ahad and his team for putting together this amazing event together and getting us all in this setting. Being the world's large facade conference, Zak continues to set the bar for excellence, innovation, and global collaboration. It's a real privilege to be a part of such platform. We have a packed day with amazing presentations and inspirational ideas in one of the fastest growing cities in the world, Skylines, right here in Miami, so it'll be exciting. Before we get started, just quick housekeeping notes. We're gonna have coffee and lunch breaks throughout the session. They're listed on the agenda. This is a great opportunity to walk around, talk to the exhibitors, see what they have to offer. They really have some cool ideas, as I had mentioned, and technologies that we can learn from. So please make sure you do that. If you're here for your AIA credits or certifications, there's going to be a registration desk at the end. You can go there, talk to them. They will go ahead and get you set up. And while you're there, you can go ahead and get your parking tickets validated, so you don't have to pay the extra parking fees. Just a quick reminder, there's food and drinks outside, but please do not bring any food into this forum area. Just keep the drinks. Only drinks are permitted. And last but not least, please return after the session is complete. There's going to be a photo session for all the presenters. So if you can please come to the stage and take a picture and a little gift from the Zak team. So with that said, we'll bring in our first set of presenters. So there's going to be two brilliant minds from Nichols Architects. We have Igor Reyes, president with decades of experience in designing cultural and civil landmarks, and Luis Sanchez, project manager with hands-on expertise in urban architecture. They'll take us through this journey of the Fontainebleau Convention Center. Please welcome Igor and Luis.
Thank you. Good morning, everybody. As he said, I'm Igor Reyes from Nichols Architects, and this is Luis Sanchez. He'll be saying all the smart stuff. I'm just here to introduce him. This morning, we wanted to talk to you about the Fontainebleau Miami Beach Coastal Convention Center. That's the actual name. It's a smaller project. We usually do big projects, but it's a really nicely crafted project. Well, you'll see it. And the facades on these are really very expressive, as you can see. We've had this relationship with Fontainebleau since the mid-90s. We've been building most of the buildings that they've built. It actually started with the number 3 here. The Tresor Tower is actually a competition that we went through to get the project. There's the Morris Lapidus building and the Melvin Grossman building. But everything else around it, we've basically been doing everything, even small little restaurant restoration for them. And then they came up and they had another project. They wanted to do a convention center. We said, where? And sort of that started us thinking of design right away, because it's actually off campus. I say off campus because you could see all the buildings are pretty much huddled in this huge site. And our site was actually this little piece here, completely separated by streets. You actually have to cross a bridge to get to it. But we thought of this as an opportunity because it is on 3 streets. It is off of Indian Creek. There's all these opportunities where this could basically be a billboard for the building. So we used a lot of the motifs that we'll go through that were already inside that the building is famous for, the Chateau building, all the bow tie, all the patterns that Morris Lapidus developed for his building. And we basically made a billboard. We call it a scrapbook of his motifs. Great views, just wanted to show you. But yeah, this idea of taking all his little you know, he was considered very sort of, I'm going to say flamboyant. You know, he was during the modern times. Those stairs are definitely not, you know, modern. He used a lot of very glamorous, you know, materials. This stair goes basically to nowhere. It's actually called the staircase to nowhere. And we sort of just took that and wanted to expand it, blow it up, make it bigger, make it building scale. We took all his, you know, pretty simple, pretty basic shapes that he played with and just sort of expanded them and made them sort of our own interpretation. And you'll see through the whole building, the facade is basically made up of these patterns. Whether it's the bow tie, famous bow tie tile pattern, or just these trapezoidal pieces that cross each other, or even taking one line and just extruding it vertically and making it part of the facade. This is a great rendering of when we were working on it. It was really sort of mixing all these things, making sure they relate to each other, because it gets sort of sloppy if you have all these crazy ideas. But you could tell the way the glass is sort of bending and sort of reflects the pattern on the walls. Obviously, all these things are lit, so they cast all these nice shadows. It's actually a really, it's a building that's going to stick out. Hopefully, it won't cause any traffic accidents, but you can drive by it and you're going to pay attention to it just because it's the way we designed it, so you can immediately see it. It is a ballroom, so it is a box. It is literally a box. We made the ballrooms as big as we could. And we even sort of hinted at that staircase to nowhere, because what we did is the function spaces are up in the air, and we actually dropped some stairs on both sides of the building that you could sort of come down and sort of have a spill out onto the sidewalk. So here's basically, as I said, it's a box with a bunch of different facade treatments. And it's actually a nice little jewel of a project. As I said, it's smaller than our usual projects, but we're really proud of the way we executed on it, which is what Louis is going to talk to you about.
Thank you, Igor. Well, good morning, everyone. It's great to be here today and have the opportunity to share the project with all of you. And so, you know, as Igor mentioned, the box really, you know, the client really needed as much square footage as for ballroom spaces as he could get on this site. So building basically, you know, extends all the way to the lot line on all sides, and we had to go through some variances to make the project feasible, to get the volume that it needed to be. So, you know, the facade was really where we had the opportunity to express the design and the aesthetics of the building. You know, there's basically three components that compose the facade, the treatment of the facade. One is the window wall system, which you see here. Then the ephes pattern, sort of the, you know, the diamond shape pattern that you saw from the scrapbook diagrams here, that clads all the solid surfaces around the building. And then at the ground level, we had this, you know, bow tie tile cladding on all the exterior terraces that come down that you'll see along the presentation. And, you know, all those three sort of came together very nicely to kind of make up the overall look of the building. Here are a couple of just simple diagrams of the ephes. So, you know, we wanted to not only express the design in, you know, in a diagrammatic way, but also, you know, with volume and you know, work with the planes and give it a little bit of texture. So we started with, you know, GFRC or precast as the first option, but the VE exercise came in right away, and, you know, we had to, you know, change, and, you know, ephes was what ended up being. And, you know, we felt the contractor really did a good job, but, you know, it's more of a labor-intensive treatment, and they did a good job in making sure that the geometry and the you know, the reveals and the panels were you know, shown the way we intended. Basically, there's two different depths. There's a difference of 3 inches in between the panels projecting outwards and the panels on the back side. These were about 17 feet long by 5 foot tall. They came in you know, separate pieces, and they were put together on site. You can see the sealant joint in between the panels there on the bottom sketch. This is just a couple of 3D diagrams of how that, you know, that system puts together, as some of you already know. So basically, there's a waterproofing layer that comes on, you know, right on the substrate, which is the Stow Gold layer, the yellow layer you see there. Then There's an adhesive that gets put on top of that where the foam panels get adhered to. And then you have your stove base coat with mesh on top of the panel, and then your finish coat. We used a smooth finish for the EFIS, and we think they really did a great job in achieving that on the system. The left-hand side just shows how the system is capped on the top with your typical metal coping wrapping around the system, and then wrapping around the back side of the parapet. In this case, we had a concrete parapet instead of a block parapet. The interesting thing is that the panels are being different depths. The coping was very getting complicated to get the coping to follow that form. So we just made it flat on the top, made it band, so the coping can naturally just continue, and the EFIS stops right below it. Here's a sample on the left-hand side of the mock-up on site. And then right here in this photo shows you kind of the way it was installed. One unique thing about it, seeing it go up, is they kind of had to draw this thing on the facade. It looked like somebody just grabbed a pencil and just drew the whole thing first. And so it was interesting to see all those red lines being drawn along before the panels came in. You see the waterproofing layer in yellow there, and then you see that the panels being installed on the north facade there. Here's a close-up shots of the EFIS. One thing we really took into account was to make sure that all the items or components of the facade follow the geometry of the pattern. So, for example, all the eyebrows that were above all the exterior doors are all angled. They're concrete eyebrows, but they're all angled and following the shape. So it was really neat to actually the mechanical louvers, from the emergency generator and all that. All the louvers actually follow the pattern too. So there's a photo that shows them as well. And you see on the left-hand side how the panels come together at the corner, creating kind of a nice texture, and the accordion feel of the window wall coming together with the linear balcony from below. So kind of a lot of texture and movement happening throughout the facade of the building. A couple of more diagrams here. So here's kind of a shot of what the design of the current wall. We didn't want to just have obviously there's a lot of opportunity with having all the pre-function areas on the perimeter of the building, and there's great views in this site. So there's a lot of glass on the perimeter, and we just didn't want to have a flat window wall. We came up with the idea of going back to the scrapbook to create sort of a kind of like an accordion or folding plane type glazing system. And so you can see there, we started with I think it was 143 degrees. Then the actual product approval, the system allowed us to go with 163 degrees, so it got a little bit shallower in plan, but it still achieved the design intent, I think, pretty well. I think a unique thing about the glass too was that the energy performance, the PVB, it's a laminated system, it's not laminated insulated, and the PVB layer and and the reflections that it required for the thermal performance, gave it a sort of a uniform look throughout the facade. So you can't really tell from the spandrel glass to the slab cover panels to the regular clear glass facing the pre-function area. So that was really neat. A couple of details is showing how the panels come together at the corners with the double mullions and the sealant joint front and back. All the joints were actually, the same size, and so all the lines were very crisp and on the facade. A couple more details. Your slab cover on the window wall system. You just anchor from the top, anchor from the bottom, and then you got your slab cover panel right in front of the slab there. Parapet detail here on the upper right-hand side, showing how the last panel gets anchored to the concrete parapet, and then you got your typical coping, your metal cap on the top, wrapping around the parapet on the back side. And then the bottom panel was actually cantilevered down. It didn't anchor to the last slab, so it basically, we had to do a little bit extra engineering and just provide metal framing below. So the last panel gets fastened to the metal framing and clipped above, and then it turns into your regular dense glass and stucco soffit below. Here's a shot of the panels being installed. Interesting to see also, the formwork of the concrete. You always see that was very important. Make sure that the edge slab was done properly to meet all the, the folding planes of the glazing system and the facade. You could also see the parapet folding all around the building, so that was kind of, unique concrete work as well. A couple of more shots of the panels being installed. Down below, you see the framework that had to be added for the last panel to be installed. Slab edges here as well. Here's a couple of close-up shots of the corner of the ground level. This is the tile cladding that I talked about earlier. It's basically a Decton tile from Constantino. It's a very nice tile, very dense, very durable, very resistive, and we like that part a lot. We also gave it a little bit of depth change. We cut the tile customly to look like a bow tie. So, that was part of the whole design concept. And it's actually at night, all these walls are lit up from below. So it has a very cool lighting effect. So if you ever drive by the building at night, you'll see that effect. This shot is just how the parapet ends on the top. So, you see the kind of the folding planes from everywhere, from the top, from below, from the front of the building. So, it's always kind of moving. Here's a shot from the interior. There's great views from this building looking west into the canal on Indian Creek. Cool thing about the interior side is that on the glazing system is that, our structural engineer, make sure that there was no additional, because, this is naturally a window wall system. You had a maximum span, I think it was 13 feet. So, we had to create structural support behind it. So we used an HSS that followed the profile of the glazing system behind, cladded it with with brake metal and same color, and so it looked very clean from the inside. So we used rods that you can see there on the upper left-hand corners that hang down from the beam above to support the HSS and also connect back to the concrete column. So it looks had a very clean look from the inside. So there was no additional steel reinforcement needed behind the system from the inside. Here's just shots of you start kind of the third component, the tile. You can see here, you really see the bow tie pattern on the tile here. They're about 24 inches in width by I think 14 inches in height. So those came out pretty neat. You see the lights below, and it's all cladding at the ground level. See a little bit of the stair to nowhere coming down from the pre-function areas above. So you're able to come down and kind of have a nice covered terrace, not only interior-wise, but also get an outdoor experience and get some activity on the ground level. So people walking by the building can also, kind of see functions happening on the building. A couple of shots of the tile being installed here. You can really see the play and the different depths of the tile. On a close-up here, also the ephes, how it comes together with the ephes pattern. A couple of shots from the west side, so you see how kind of all the treatment comes together. You see bottom left-hand side, kind of the eyebrow there. You see the ephes right above, and then the glazing pattern. Being angled, you see get different shadow lines and different sort of reflections on the facade. And this is just kind of an overall shot of the building from the west side that, kind of shows how everything came together. And this is, pretty much it. Thank you so much.
Thank you, Igor and Louis. That was really nice. As a consultant, I can really appreciate all the challenges that you guys have to go through to get this project going. Next up, we have, talking about technology and performance, we have John Kilpatrick of RWEDI. He's a principal, and he has over 30 years of experience in engineering and climate response. He's going to talk about AI tools and how cladding systems in the early design process can take benefit from that. Please welcome John.
Thanks for having me. It's a great opportunity here. As mentioned, I'm John Kilpatrick. I'm a principal at RWDI. I'm not sure how many people have in the audience will be familiar with the firm, so I'm going to spend a few minutes talking about RWDI. But the goal today is really to focus on tools that we might use early on in the design process. Let's kick off here. RWDI's reputation is really built on wind engineering. We've worked on 16 of the top 20 tallest buildings in the world. We don't just work on high rises, we work on stadia and airports and all sorts of other facilities. One thing that links everything together, and we offer more services than just wind, but the one thing that links everything together is the climate. So what the effects, climate and environment, what are the effects of wind, rain, solar, snow, sand drifting if we're working in the Middle East. So all of these problems are linked by climate and the wind. All of these services that we offer really have to, we're thinking about the human experience. You know, how do we interact in the built environment? How can we make that interaction better? And ultimately, how do we maximize the performance of the projects we're working on? One of the interesting things I think about RWDI, we're a little bit different. I know in the audience there's architects and engineers here. We don't really design anything, which is kind of good in some cases. But we have a lot of deep technical expertise, and we consult on most things that affect you folks. We're known for our climate labs. On the left-hand panels, you see a couple of images from our wind tunnel facilities in Canada. We can do some large-scale tests there. So that's, it's obscured by the smoke, but Shanghai Tower is in the background there. So we go from something like one of the world's tallest buildings to something as small as ground mount solar arrays. And those are interesting in themselves, and there's a lot more failures in that field that makes it interesting to work in that. On the right-hand panel, we have something we call a water flume. It's a bit like a wind tunnel, but it uses liquid instead of air as the fluid. And we can use that tool to look at things like snow drifting or sand accumulation. So in northern climates, that's important. You know, down here, snow drifting and on roofs and things like that, not such a big deal. But in the Middle East, we use this tool frequently to look at things like sand drifting on transport networks and things like that. Increasingly, we're using digital tools as well, like CFD and AI, what I'll be talking about today. We have about 30 different offices around the globe, and we have 3 of our centers, one in Canada, one in the UK, and one in India, where we do have testing facilities. So we operate around the globe. We work on a lot of global projects, but we do practically everywhere I've ever been, there's more than a handful of projects we've worked on locally. So these are just a few examples of projects here in Florida we've worked on. A little bit of background about why, what we do and why we've developed some of these tools or innovations. And I'm talking specifically, because we're here at a facade conference, I'm talking about wind loading on buildings. And the framework we use to think about wind loads on buildings, something we call the wind loading chain. And it's illustrated there on the screen, but the wind load on a building is a function of a number of things. Not only the wind climate or wind speeds in the region, but where is the project sited? What kind of terrain do we have? What's the building look like, and what are its basic aerodynamic responses? Is there any dynamic responses? And ultimately, all of these designs have to meet some performance criteria. So when we look at a wind problem, we're using a wind loading chain kind of as the lens for looking at that problem. Now, if you've used the building code before, and probably a lot of you have, the concepts in that wind loading chain are embedded in the codes of practice. So this is the ASC 722, and it's the approach used to calculate component and cladding wind loads. And you can see parameters in that process that are related to wind climate. You can see parameters that are related to the site exposure. And you can see parameters that are based on building aerodynamics and gust factors. Gust factors being representing the dynamic part or mechanical part of the problem. So it's great, you know, we have this tool in the wind loading chain that's baked into the codes, but the codes are only applicable to certain types of structures. And that's why we get invited onto projects. So the code applies to buildings that have regular geometry and don't have response characteristics that make the building vulnerable to a crosswind loading, vortex shedding, instabilities, channeling, or buffeting from upwind structures. So that's really good advice as it relates to the code. I think the difficulty comes when you're working on a project and it's either a really unique geometry like the one in Top Center, which is a museum in France. And, you know, thinking about the code, you might say to yourself, where does zone 5 and zone 4 begin and end, right? Now you've got other interesting shapes in there that probably fall outside the applicability of the code. And that's where we get contacted to come in. And we typically do wind tunnel investigations, which I'm done speaking about for now. I'm going to be talking about other advice we can give early on in the process. A wind tunnel test itself, okay, so I'm not done. Maybe one more minute on wind tunnel testing. It's a process, and it takes time. So to build a physical model and put it into the wind tunnel and test it and then analyze those results is a process that might take 5 to 6 or 8 weeks in practice. And we hear a lot of questions from our clients saying, well, what can you tell me? What help can you provide early? Because 8 weeks is a bit of a long time to wait for something when my process is evolving on a daily basis. So we're talking about AI tools and how they could assist in early design. What do we mean by early design? Well, usually concept design, permitting, schematic design, but I'm even thinking about things like design competitions where we might be contacted and a customer is looking for an edge to make their project more appealing to the developer. What can you do? Can you tell me what the benefit of doing wind tunnel tests might be, and can we bake some of that benefit in now? Is there anything unusual about my project that you can warn us about, and we can take that into, you know, further into the competition or design process? So there's a lot of, and then there's a question on the top center that does happen from time to time. You know, you'll get a client will approach us and say, hey, we've got 5, 6, 7, sometimes we've seen 10 different initial concepts about a building's geometry or plan form, and they'll want some initial advice. You know, which one's best? You know, is it B better than A? Is C better than A? And is it better than B? So that's difficult. Those questions are actually quite difficult to answer precisely that early in the process, but that doesn't stop anybody from asking the questions, and it sort of puts the onus on us to say, what can we do to provide those answers? One of the common questions that comes up is, do we think there's a benefit in doing wind tunnel testing ultimately on this project? It might be a tough sell for a modest project to do a wind tunnel test. This graphic just shows for a number of buildings ranging in height from about, apologies for the metric units, 70 meters to about 160 meters. And the dark blue lines identify the result we measured in the wind tunnel, the light blue being the code loads. And what the graphic shows is, yeah, there is a benefit, generally speaking, from doing the wind tunnel test. So there's an opportunity to reduce the materials being used, reduce the embodied carbon, reduce the loads, change the glass specifications, etc. So we can advise on a lot of different topics, but what we're focusing on right now is cladding pressures on the buildings. And AI. So one of the things here I'd like to show, left to right, is kind of the tools we have to do our work. Firstly, the dots in all of those plots are wind tunnel results. So these are wind speeds at the surface, which you might be concerned about if you're looking at an amenity space around a building. And on the left is something called Reynolds average Navier-Stokes, CFD. It's pretty good at giving you the mean wind speeds. Large eddy simulation, CFD, it's a little bit better. It handles turbulence and gustiness of the wind much better. And then on the right, so the CFD processes, I should say, can take days to weeks typically to run before you get results. It's still faster than using the wind tunnel, but it's not as precise, and codes, with AHJs generally don't accept those for final design purposes. But for the purposes of making decisions early, I think they're very powerful tools. The one on the right is an AI-based simulation. And the benefit of AI is this can be done in 10 or 15 minutes instead of days to weeks, okay? How does it do that? Well, so AI has solved a really interesting problem for us, and so we're not, the only thing we can really take credit for is having a whole pile of data. For decades we've been doing wind tunnel tests. We record the data, we know the building geometries and the surroundings that we've tested. We provide our clients with advice, and when we're done, we shove all that data on a server and probably never look at it again. And we've always thought that's a shame because there's valuable information buried in there. And from time to time, we'll blow the dust off of an old study and because it resembles something we're working on with a different client. Well, now we can actually use that data to train these deep learning models. And the models basically will, eat up all that data. And when you feed the model the current building geometry and the context model of the surroundings, it'll then basically use the previous wind tunnel data to infer what the distributions might be on the new project. And again, it's a process that takes maybe 10 minutes, 15 minutes to run. I was a bit of a skeptic. I've been doing wind tunnel testing for 29 years now. And so I'm quite comfortable with the physical testing. I know the limitations. There's always been a discussion about digital tools, and well, they're not ready yet. They're 10 years away, but I think they're ready for the things I'm talking about today, these early design tools. So the simulations are quick. You can calculate pressure coefficients on buildings very, very quickly. You can combine that information with project-specific wind climate data and reflect the influence of surrounding buildings. You can calculate pressures at multiple return periods, maximum and minimum of pressures. And those results can be presented either in a 3D viewer or a report. So one of the things we're trying to do here with the tools, identify, the project specifics, and I'll show a few slides in a minute with examples. But, there's only so much you can do with the codes. It's a great starting point, but they don't really reflect any project specifics. The geometries the code are based on are basically rectangles or cubes. Very simple. Actually, usually the wind tunnel test the codes are based on, there's no surrounding buildings. And, a place like Miami, you have a very different environment, obviously. So with these tools, we can predict pressure distributions on building that are a bit more specific to your projects, give you more insight than a code would, and then hopefully help you address questions that come up earlier in the process to keep that design moving. This is an example. I've called it architectural shaping. It's a very basic one, but we've got 4 different shapes there. A rectangle on the top, a circular tower on the right. Again, very simple examples. A stepped tower on the bottom left, and a tower with what we call wind floors or blow-through floors. Buildings like 432 Park and other super slender buildings have these. But what you can see from here is how the pressures vary on the envelopes for the different types of geometry. And understanding how the pressures vary early when you do have a lot of different concepts is useful. The output from the analysis is very similar to what you'd get from a wind tunnel test. It's a preliminary distribution of pressures. So I think it's useful if you're costing a building envelope, for example, which I know somebody at some point in time is going to ask you how much it costs. A few examples of validations that we've done. This is a tall building. And, one thing you'll see, there's a strong correlation between the machine learning or AI predictions and the wind tunnel, but it's not perfect. I just want to be clear about that. It's not going to give you the exact same answer as the wind tunnel. On average, it'll give you a good answer, and I think early that's helpful. But you have to be mindful that it's not the same as a wind tunnel test. So there's a trade-off in precision for speed, let's say. It's another example of some pressure coefficients. The blue dots are pressure coefficients from the wind tunnel for a particular tap on this building. And the red is the machine learning result. So what you've got on the top is minimum, maximum, and mean pressure distributions. And you can see the trends and even the peaks are reasonably well predicted by the tool. So again, good news. This is another project example. It's a tower in the UK that actually the interesting thing about this is it was never wind tunnel tested. When it was built, there were some envelope failures. And so we initially did a wind tunnel test, which are the results on the right, which indicated a very high suction where the tower and the podium intersect. On the Eurocodes, or the British annex to the Eurocode, there is some advice that would identify that that's a hot spot. You could expect high pressures, but I don't think that was found in the initial analysis. On the left is, what does the AI study tell us when we look at it? And the AI here is successfully identifying that hot spot at the intersection of the tower and podium. So we see things like this as a way to identify issues in design before they come back to bite you. So I know we're coming up to the end of this presentation. So really, we're trying to offer help to the design community, and we think there's a demand for these early tools to help with design. We've worked on this innovation, and right now we're using it on projects with clients, and we'd love to know from you guys if there's other opportunities to inform your process. So thanks very much.
Thank you, Jack. Thank you for this fascinating look at a predictive AI. Thank you.
Okay.
Next up, we have John Redden of ES Windows. He brings 20 years, two decades of experience in design of facade systems. He's going to talk about how curtain wall systems can enhance technology today.
Good morning, everyone. Where was John's presentation 10 years ago? I could have invested in AI and NVIDIA at the time and been retired on a beach somewhere, but 10 years too late, damn it. As the gentleman said, my name is Zak Redden. I'm the Director of Architectural Sales for ES Windows. I've probably been in many of your offices. Most of the folks down here in Miami are familiar with ES Windows. For those of you that are from different areas, maybe Central Florida, Northern Florida, possibly out of state or out of country, quick little introduction on who ES Windows is. We are part of the Technoglass Group. Technoglass is a publicly traded company on the New York Stock Exchange, for those that are in the market. And ES is we recently relocated our corporate headquarters to Miami, but our manufacturing footprint is still in Barranquilla, Colombia, which is the northern tip of South America. So this is actually an aerial shot of our campus. Some of you may have actually come down and toured. We do a lot of architectural tours, developer tours, GC tours. For those of you that have not seen it, this picture really doesn't do it justice. It's a massive scale. It's a dozen different buildings on our Technoglass campus. And you'll see these different logos from Aleutians, Technoglass, and ES. And what you're looking at here is the wonder of our vertical integration. So we are very proud of the fact that we are fully vertically integrated. What are the two primary components of commercial aluminum windows? Aluminum and glass. So we actually fabricate all of our own glass in-house. So all those buildings that have that Technoglass logo on it, Technoglass is not only our parent company, but also our glass vendor. So we're actually laminating, insulating, applying low-E coatings, fully tempering our glass in-house through Technoglass. Likewise, on the extrusion side, through Aleutians, our other sister company, we actually have a foundry on site. We are pushing our own aluminum profiles and painting them with high-quality Duranar, Kynar finishes, up to a 20-year finish warranty. How this benefits you all, developers, architects, GCs, is that it allows us, since we are our own supply chain, it keeps our lead times incredibly consistent over time. We don't have a lot of peaks and valleys as far as our lead time, so it makes planning a lot easier on projects. Obviously, since we are our own supply chain, we can institute some pretty robust quality control mechanisms. Some of that we'll talk about as far as helping us get really pristine product out into the marketplace that's going to look aesthetically beautiful for your clients. And then most importantly, I'm going to show you some really cool project case studies. This stuff looks amazing, very high performance products, aesthetically pleasing. But we wouldn't be as successful as we are if we weren't delivering that product at a very attractive price point. So that vertical integration really does allow us to get this product into market at a pretty competitive price point as well for your clients. So some of the design trends that we're kind of always looking forward, trying to stay ahead of what we see the market doing. So one of the big design trends that we've seen over the last 10 to 20 years is glass sizes getting larger and larger and larger. So we're trying to stay ahead of that with our jumbo size glass capabilities. So these are our sheet size capabilities. What this translates to as far as unitized window wall systems and curtain wall panels that we're going to be talking about. We have several window wall systems, for example, where we can go north of 20 feet vertically without any horizontal structural breaks. So very, very large sizing capabilities. We also want to make sure that we deliver these large curtain wall panels and window wall panels to you, that we're not doing it with monstrously bulky frame profiles. You don't want to have a $5 million or $10 million view out of your Miami Beach condo and be looking at, monstrous 6-inch mullions. You want to have very narrow sight lines. So we're balancing that performance, but still keeping those sight lines very, very modern, sleek, and narrow, which is what's very attractive to clients these days. We do all of our own low-E coating in-house. We are licensed to do Vitro's Solar Band 70 as well. We have 14 different low-E coatings, so we basically give architects like options. So we have a wide slew, like I said, 14 different mixes of low-E coatings, different aesthetics, different exterior reflectivity. So really depending on what you're trying to accomplish with your exterior facade, we have a low-E coating for you. These coatings can be applied to clear glass, low iron glass, or tinted glass, and we'll show you examples of all that when we get into the case studies. If you're wondering if this is a real building, the answer is no. I called BS on my marketing department, but it's beautiful. It does. Thank you for the laugh. I appreciate that. It does showcase just some of the potential capabilities of this Technoband technology. So this is really becoming very, very popular, especially the last 5 years as the prices started to come down a little bit. There was some Some technology challenges with bending, like low E coatings and frits and stuff like that, but the technology has really come a long way, and the price has started to come down a little bit. So if you use it judiciously in certain feature areas of your exterior facade, it can be really a nice way to really just bring that facade to life and create a kind of a wow factor for your client. And again, if you're using it just in a certain area, it doesn't necessarily blow the budget. Although we know budgets are limitless down here, right? Some of the quality control mechanisms that we've instituted, one of them on the glass side is, I could speak for an hour just about this air cushion technology, but what I really want to talk about more is actually the quality control. So we actually scan every single piece of glass that comes out of our tempering furnace looking for hot spots. So we want to make sure that it meets our internal threshold for flatness before it goes out onto the manufacturing line. If it doesn't, we grind it up into collet and recycle it. If it does, it goes out to be laminated, insulated, etc. And what we're trying to do because of this internal quality control, if you will, we can guarantee you what you're going to see is glass like what you see on the image on the right here. So what you're looking at here is low distortion using this air cushion technology. You can see the reflection of the building there. Mirrors reality quite nicely versus the image on the left, which is exhibiting something that we call roller wave distortion. So that's kind of an antiquated technology. Potentially when this annealed glass is superheated to 1400 degrees in the tempering furnace and it's carried on ceramic rollers to an area where it's rapidly cooled, it is susceptible because it's in that semi-molten state to getting what we call that roller wave distortion. So a lot of people call it funhouse glass. There's nothing fun about that. I'm sure you and your client would prefer the flat glass on the image on the right. So that's what we can guarantee with our products because of this quality control that we've instituted. Same thing on the extrusion side. We have some quality control metrics with elutions. As I mentioned, we're painting these up to 20-year finish warranties with Kynar Durnar. If you're not familiar with the AMA 2605 specification, AMA is kind of a big deal in the fenestration industry. I used to offer $1 if anybody could tell me what AMA stands for. I've only paid it once in 20 years, so I'm gonna take a shot. Does anybody want to take a shot what AMA stands for $1? No Googling, no Googling. You just Googled, you're disqualified. Plus you look like you know the answer, you're disqualified. Anyone else but him? No, go ahead. I'll give you 75 cents. You got 3 of them correct, so we're going to prorate it out for you. But it's the American Architectural Manufacturers Association, and even if you're not familiar with them, I guarantee you that all of you on the design side have specified an AMA 2605 performance spec. If you're familiar with Kynar, Kynar is a fluoropolymer resin. One of the ways that you can meet that spec, it's a very robust spec, and it's really the only spec you should be specifying. So AMA has these 3 different performance levels. And 2605 is the Rolls Royce. It's the best finish that you can specify for your client. Here in South Florida, where the UV is brutal, blowing sand eats through paint, moisture, humidity, salt spray, this is the only paint finish you want to attach your firm's reputation to, and I'll show you why. So basically, to pass this standard, if you will, this paint finish needs to go through a robust set of testing. I'm not going to go through all of it, but we actually have a mini AMA lab at ES Windows where we randomly audit our extrusions. And we score it. We try and pull it off with tape. We'll load it up with a drop dart and dent the aluminum, try and pull it off in that concave area, blowing sand, etc. We want to make sure that you guys have peace of mind that your architectural design intent will last in year 10 and year 20 and look kind of what it looked like when you handed the keys over to your client. If you specify this finish, that will be the case. So this is the paint farm, for lack of a better word, that we have here, where we have all these different samples. And I need to speed this up. But basically what you're looking at here is they protect these samples on the top and then kind of let Mother Nature do what it does to the exposed area. And you can kind of see the difference over time. So what you're looking at is the original color on the top that was protected. And then you can kind of see what Mother Nature did to it with that UV exposure. So those 2 samples for 17 years for those darker bronze. We're starting to see a lot of bronze and black colors, a very trendy color these days on aluminum profiles. You can see that your color has held very, very well. I don't think your client would be happy with the silicone poly or the acrylic, so bottom line is stick with that 2605, and that is our standard spec for our products. So we're talking about hurricane-rated systems here, but if you're doing projects up in Central Florida or North Florida or out of state, we have a robust portfolio of non-impact products as well. We're going to talk about window walls and some of these design options here. This SSG, where is it? They told me how to do this. I apologize. Yeah, the SSG mullion, that's becoming very, very popular, where you kind of have glass to glass and the mullion is set beside it. It really gives a nice, sleek, and ultra-modern look versus the more traditional captured mullion there, where you can see it from the outside. So we offer both options for window walls and for curtain walls. I want to get to the project case studies. I apologize. I'm blabbing too much, I guess. I don't want the big hook to come out. So pre-glazed systems versus on-site stick assembly, we offer both. We really do like to push the pre-glazed factory glaze because we're actually pre-glazing these panels in our climate-controlled warehouse, manufacturing facility, if you will. So you don't need to worry about things like construction dust, UV impacting silicone cure times, all that kind of stuff. So it's silicone is pumped and metered and cures in a controlled environment. You don't need to worry about sun and humidity and all that fun stuff, versus stick by stick and glass on site, which is really not ideal for large projects. So what's going to show up in these large panels that snap together from our glazing subs? And it really is the most optimal way to close in these large exterior facades extremely quickly to allow other trades to come in on time or ahead of time and allow these projects to finish on or ahead of schedule, which is what we all want here. So pre-glazed, we feel, is the way to go for these large projects due to all those benefits. With curtain walls, we have the same options as with window walls, SSG profiles and captured. We can integrate things like vertical fins, custom sunshades, stuff of that nature to control for glare and just add some architectural pizzazz to your exterior facades as well. This is a good example. The picture on the left showing you that four-sided captured versus the bottom right hand, which is that butt glaze type of look where the mullion is set behind that SSG look. So we offer both of those. Even complex geometry is a couple local cruise terminals for Royal Caribbean and Norwegian. Royal Caribbean on the left, more angular slope glazing versus the Norwegian, which was curved. To speak to the power of how quickly these unit sizes can close in those envelopes, the Norwegian project finished 6 months ahead of schedule, and the GC credited the coordination with our glazing sub in the production and just how quickly that facade went together to really keep that product ahead of schedule. It also won a Transit Project of the Year back in 2021. So we play in a lot of different segments, not just high-rise condos. We get into healthcare, education, and not just South Florida. So if you're doing projects in Central Florida, North Florida, or out of there, we love to consult with you on those opportunities out of state as well. We talked about the Norwegian project. Again, just a massive curtain wall project, unitized with some custom curved geometry. That was a fun one. Terminal C, this is close to where I live. I'm based in Orlando. This is 10 minutes from my house. Won several transit awards as well. We did all of the interior, exterior glass, low iron glass, ceramic foot patterns, stuff like that. This was a real fun project in the healthcare segment that we worked on with HOK, provided the design assist. So we had the challenge of having this custom radius curtain wall system on two different planes. So we had to figure out a way to connect these two different planes and handle the geometry of this. And this was the easy elevation, believe it or not. On this elevation, what they wanted was this monstrous custom curved sunshade system, which we also did through our sister company, ES Metals. So we were able to provide design assist on both the glazing as well as this custom sunshade. The challenge for our engineers was to figure out how to mount this monstrous sunshade to the SSG curtain wall because you have glass to glass. It's kind of hard to mount it to the glass and silicone. So we came up with a cool little knife system to mount this monstrous sunshade. So this is the kind of stuff we love to get involved in, so we encourage you to engage us early on projects, especially complex stuff like this, and let us work our design assist with your team. This is showcasing some of our curved glass capabilities here. Kind of the running joke here is they only did the northeast elevation because they couldn't afford to do the other three corners of the building, but this is to my point. Curved glass can be a very dramatic feature, especially if it's used judiciously. And here we did this with a custom curtain wall system curved for 830 Brickell and a high-rise application. This was an amazing project that really launched a whole new division for us called our structural glass systems, our SGS, brand new this year. Really in the lobby, what we did is the client wanted this 34-foot tall glass lobby, and we basically built the full-scale mock-up and tested it. We needed to hit a 75-75 for DP. We actually hit an 86-86. And we developed this custom glass mullion. So we can do these glass fin structural systems with no aluminum, which is what the client wanted on this one. Another big trend we're starting to see here is mixing different tones of glass. So on this particular project here, we have Oh. I didn't understand it either. So on this one here, we're mixing blue tinted glass with clear glass, all with a reflective coating. So on the south and north elevation, we used solar blue. The middle areas, we used clear glass. We also did some cool things where you can kind of see here on this elevation. Keep pushing the wrong thing, I apologize. We did basically extended caps on the horizontals, but a SSG for verticals versus this elevation here where we did all four sides in the SSG. We did the opposite on Miami Paramount Tower, which is actually the America's tallest LED lighting system, puts on a Vegas-style show at night if you're familiar with the project. But I apologize, the picture's kind of grainy, but on this one we actually did the opposite. We did SSG horizontals for the window wall, and then we did vertical captured where we elongated that out, and it puts on a pretty incredible show. Same thing on this one, mixing two different tints is very trendy. So the center area is a very deep blue, a Pacifica blue tint, where the side areas are clear, all again with a reflective coating. One thing in closing, because I'm over time, I apologize here. If you have a client looking for blue glass, but they don't quite have the budget, because I will share a little secret if you don't know about blue tinted glass. It is very, very expensive to source, and sometimes it can be rare to source. Vitro only does a couple runs a year, and when they're out of Pacifica blue, they're out of Pacifica blue. So if you have a client that likes that aesthetic, but they don't quite have the budget for it, I would recommend one of our clear samples with our low-E coatings like our N4825. If I asked you what color that building was, you'd probably say blue, but that's actually clear glass, believe it or not. So clear glass with this N4825 has that bluish aesthetic at a fraction of the price of a blue tinted glass. So just something to keep in mind. We do punched openings as well. Large punched openings that you're seeing here, very modern. We can also do large punched openings with mullions and buttons to kind of create this historic vibe. So again, depending on the exterior facade and the look and feel of what you want for the building, we can do two different things and to have two totally different looks depending on the aesthetic intent for your client on the project. So with that, I'm over time, so we're just going to scan to the end and say, if you haven't already come over to the booth, come visit me. Otherwise, hope you enjoy the show, and thank you for your time and attention. Appreciate it.
Well, thank you, Jack. Thank you for this amazing presentation and showcasing the power of pre-glazed systems. Next, we have Jac Selinsky of Raphael Vignoli Architects. And he will be talking about the Faena residences with two twin towers that are connected by a beautiful and amazing bridge.
Good morning. I'm Jac Selinsky, director at Raphael Vignoli Architects, and I will be presenting this this project, Faena Residences Miami. So this is we're still designing this project. It's currently starting construction documents, so the presentation will be a little less technical than some of the others. But given that it is a project that's been kind of in the the public consciousness for about 10 years in Miami, when we started design, we thought it would be interesting to just show everyone where it's at now and what will be going into construction early next year. So Raphael Vignoli Architects is a New York-based architecture firm with offices in Montevideo, Uruguay, and London. We're very fortunate to have projects all over the world in almost every market sector, including some very prominent high-rise towers that you might recognize, like 432 Park, 125 Greenwich, Neom in Chicago, and the fourth tallest one is our project in Miami, the Faena Residences. Our office works in a very model-based process. Basically, with Raphael, who passed away 2 years ago, but who led that methodology where traditionally we always worked in physical models, and then when along came 3D modeling and tools like Rhino, he actually sort of set the tone by learning it in his late 60s, and our collaborative process would be one where he would actually be doing a lot of the modeling, and we'd use that as a communication tool between us. So it's a very sort of unique unique way of working within a large architecture firm. And we also place a very large emphasis on collaboration. I think one of the things that really made Raphael an incredible businessman and architect was his emphasis on collaborating with his clients, really understanding their business models or their institution's mission or whatever it may be, to develop a design that solved the problems or investment needs that they had, while also creating something really important for, really contributing to the public realm at the same time. So talking about Faena Residences, the project team is Fortune International Group is the developer who has partnered with Car Properties, and Faena Group is their branding partner. The structural engineer is MKA, working with Cosentini on MEP, landscape by Sasaki Associates. Intuitive has been the enclosure consultant on the facades. Brian O'Sullivan Studio on interiors, and L'Observatoire on lighting design. So the project is situated along the Miami River, close to where it enters the Atlantic Ocean, kind of on the dividing line of Brickell City Center and downtown Miami. It's part of a large growth of residential developments in the city. As we all know, it's been a kind of a boom town as of late. It's surrounded by 3 other towers that were all part of sort of the same multi-phase development or zoning lot. And ours is fortunate, I think, to have by far the best site placement. So the program of the project is it has over 400 residences, over 1.5 million square feet. Over 250,000 square feet of balconies, over 34,000 square feet of indoor amenity spaces, and 45,000 square feet of outdoor amenity roof terraces. So it's a very large project. The primary views are of course, Brickell City Center, directly south of the project. If you have a high enough level, or so also the Miami River, the Atlantic Ocean, Biscayne Bay to the south. So, like with every project, we went through many amassing iterations of single towers, of multiple, of dual towers, to try and maximize the views and optimize just everything about the site. And what ultimately we arrived at was a split tower scheme, with 2 sort of conventionally rectangular buildings that are situated in a way where they each have optimal views of either the Atlantic Ocean and the river, or Brickell City Center and Biscayne Bay, but they do not obstruct each other at the same time. And then by creating an elevated podium and a sky bridge that links them up at the top, you get this form which has residences with unobstructed views, and then at the same time adding this element of visual drama to the building that we feel will create an important sort of iconic landmark within the city of Miami. And then this is the view down the Miami River near the opening to the Atlantic Ocean. At the ground floor, or at the ground level, we're contributing to the Miami Greenway. And I believe, and it's connecting 2 finished portions to either side, so it'll be a very nice contribution to that sort of linear park walking path. These are some images of the landscaping by Sasaki and the water features that are going to be included. At the ground level, we have the main residential entrance along the 45-degree axis, which is a porte cochere under the overhanging garage podium. It extends pretty far to the north and then over to the west, because with the split tower design, the cores are over at the far ends of the building. And then with the commercial entrance off the west elevation, which takes people up to the sky bridge. This is a typical floor within the elevated podium. So it has parking and then also what we call river lofts to take advantage of the views of the river. This is the roof of the parking podium, which contains, which houses the sort of residential amenity pool deck and fitness spaces and wellness spaces. And so this is kind of the primary amenity of the residents of the building. In the tower, so we have two, fairly conventional rectangular towers with hit the back button, with the cores positioned on the back of the building so that the units have, are just sort of like very optimally laid out in order to, to capitalize on the views that they're facing. They're only about 35 feet deep. So it works out to a very advantageous sort of plan configuration from a unit layout standpoint. Up at the Sky Bridge, so this is the 60th floor, which connects the two towers. This is a very large, not an amenity space, but a commercial space. So this will be like a club that's operated by the Faena Group. It can be used by residents of the building, but also people who belong to the club as like guests. So there's a large 2-story event space in the middle, restaurant on the east side of the tower, a lot of meeting areas and sort of programmable spaces like that throughout the rest of the space. And this is the second floor with the 2-story opening. And then so the roof deck of the Sky Bridge, this is called the beach. So sort of bring Miami Beach to 700 feet up in the air in downtown. But this is the part of the Faena Club, which will have an infinity pool overlooking the Brickell Center and the ocean, sort of similar to some other Sky Bridge projects around the world. And then so some more indoor amenities as well as privately owned cabanas along the pool deck as well. And then penthouse levels. So then in terms of the building facade, it's in a way, it's a very conventional wraparound balcony residential building. But what it attempts to do is to sort of uniformly lay that out to use the balconies and the guardrails associated with it to define the mass of the building. So one thing that's super important to the design of this is actually to enforce the floor slab lines of the balconies. Raphael's mentality with project designs was always like, if you have to do something, then sort of like do it all the way and make it the main feature of the building. So I think whereas many residential high-rises, that have balconies, the balconies tend to detract from the building form. But this building, uses them as a very monolithic element, sort of uniform element all the way up the building to define the form of the building rather than to be something that's sort of added on. In terms of the building enclosure, so we have been working very closely with Technoglass and ES Windows on all of the systems. So this is an ES window wall with integrated sliding glass doors and an ES Windows guardrail system. The glass selection is it's Technoglass 3623, and we selected that for its high level of reflectivity so that when you're looking at the building, you see a very consistent appearance of the glass rather than, sort of seeing the differences between people's units and what kind of drapery one, resident has versus another. And then the paint color of the mullions is meant to blend as much as possible with that. So the end result is intended for the window wall system to look fairly monolithically and allow the balcony system to be what is highlighted and predominant in terms of the visual expression of the building. So in order to do that, push the back button. So in order to do that, we are using a point-supported guardrail system where the glass overhangs the floor slab. And then along the floor slab, we're changing the SGP interlayer from being a clear interlayer to a white interlayer. And so what that allows us to do is to make the appearance of the floor slab a little bit larger, but also make it very clean, very sort of like well-defined as a white band rather than sort of, the floor slabs can be a bit messy. So it will really, help to emphasize it from day one, but also, years down the road where, the building gets dirty and needs maintenance, it just sort of ages. It will still keep a very sort of, as intended appearance of the building. And this is an interior view. And then this is how we always select our glass. It may look like they're posing for a boy band album cover or something, but we have this little rig that we bring out to the terrace and look at glass from interior and exterior, and that's how we do it. So the Technoglass is there on the right, and we were benchmarking it against a couple of Viricon samples that we use often, and they were all really nice. So the Sky Bridge, which goes from level 60 to 63, is definitely going to be one of the biggest challenges that we face in this project. So it features, like I said, a two-story space in the middle, which is kind of a programmable event space for, events or weddings or whatever is needed. As opposed to the tower, where we're attempting to make it very reflective and not necessarily transparent. In the bridge, the intention is to maximize the transparency through it from one side to the other. Keep hitting the wrong button. Sorry. So you can see along the front of the curtain wall is a two-story steel truss, which braces the two buildings together, and actually has the benefit of really stiffening both buildings together to the point where there's no need for any sort of tune mass damper or anything like that to deal with building sway, because the two buildings are oriented 90 degrees to each other, and then with the structural element bracing them together, they're incredibly rigid. But some of the challenges that we're going to be facing in this project, which make it an interesting project to work on, are surrounding the structural framing of the building. Right now, we're working on working with steel fabricators and erectors to figure out or to work through how will the steel bridge or how will the bridge structure actually be built? Will it be stick built in place? Will it be partially fabricated on the ground and then jacked up into the air? Many of the members, the members that make up the truss are too heavy for a conventional, tower crane to pick up. So it becomes a very interesting logistical challenge. On top of that, there are factors like analyzing or designing the curtain wall to the kinds of deflections that the building will experience. Because not only do you have the sort of conventional, floor line, deflections that you would design for in the residential spaces, but you also have deflection over the entire building. And how does that affect the way that the curtain wall units stagger, as they go across? And then things like, this infinity pool at the top, how, making sure that it maintains the sort of same or like a consistent, waterfall appearance when the building is moving some. So those are some, really interesting challenges that we're working through right now. And this is a section through it, so you can see the two-story truss that primarily, how do you do this thing? The skyline, yeah, never used this before. So, you can see the two-story truss, which braces the buildings together and is kind of like the primary load carrier of the Sky Bridge. and then a cross-directional truss which supports the pool and the sky deck as well. And so this is a view of the tower top and the sky bridge, the waterfall edge at level 63. So then down on this, down on the street level, it's very important to kind of like break down the scale of the building from its sort of, massive scale down to a human scale. So our approach, as we designed these spaces was definitely to sort of prioritize the indoor, the interior-exterior continuity of the design. So sort of playing off the themes that are being developed by BOS, who's the interior designer of the project. But then to sort of use the building's geometry to frame those elements and kind of like fit them within the overall order of the building. So this is the porte cochere along the at the main residential lobby, which it helps a lot that the parking podium is raised by 2 stories. It kind of creates this kind of exterior, kind of like living room feeling within which to sort of like house this porte cochere. So it's it's an outdoor space, but it very much feels like an extension of the lobby. And then on the west elevation, so this is where the commercial entrance is this is where people would come in order to go up to the sky bridge, sort of using the building geometry, like I said, in terms of the overall elevation and the way things are ordered, to create this like slot which has a very specific identity to it and a sense of arrival. It kind of stays within the rules of the general building, but has this differentiated personality, which I think is working extremely well. And so this is another view of the drop-off. And then one final feature of the project, you probably have noticed some artwork on the building. So that is a collaboration between the Faena group and an artist named Juan Gotti, who they have collaborated with. They have a close relationship with, and collaborated with on their Miami Beach project. There's several artworks there that are publicly viewable. And this is sort of intended to be kind of in the tradition of projects like the Bacardi building, sort of creating this public artwork that's integrated into the building design. So that is, looks like I finished a little early. So that is the Faena Residences Miami project. Thank you for here.
Thank you, Jack. That was really, really impressive, and looking forward to seeing this come up. And now we're going to take a short networking break, so you guys can feel free to go out and network and talk to and see the exhibitors and hopefully see some interesting things out there. Please welcome him as he talks about the Carnivore Center at Brickell City Center.
I guess to jump right in. So I'm Zach from Socotech, a multidisciplinary firm, consulting firm. I work in the envelope division, which is what we're talking about the Vassier Center today. In particular, just kind of its uniqueness to the Miami market and some of the challenges that we went through along the way. So for those that are familiar with the Miami market, I'm not certain how many here are or not, but this is across the street. So when you came onto the quay, it's on the left side. It was an existing building, 2 existing buildings that have a kind of a common cellar level and then an adjacent parking garage. And the design team on this, which is Architectonica, had programmed kind of an elevation of the new facade. So bringing it from kind of into the modern world, Class A office space, and some of the interior renovations, as well as connecting the two by way of a connecting lobby in the middle, which you see is kind of in this picture, the green there. Here we go. So just, throughout the presentation, mainly images so we can kind of see the progress of the project, but talking through the full life cycle of the job itself. So starting with the feasibility, the job started for us kind of as a thought, like how do, the owner came to us and said, we're looking to do something. What is that process? Does it make sense? Both from an integration perspective, from a monetary perspective. So we started working on the project, I think it was in 2020, and it just wrapped up last year. While ordinarily you don't think that COVID or that time frame would have been beneficial to the job, I think in this instance actually it was. And we can get into that a little bit more. So really kind of breaking it up into 4 major topics. So the feasibility, what can the local market offer, with our impact requirements and kind of what's available here. The procurement process, here we had a GC and a subcontractor who is Alpha Cladding. And then, how do they install it? What is their sequencing? So from a feasibility perspective, like I said, we got involved very early with the architect, kind of call it concept design level. One of the challenges were, what does the facade want to be? Window wall, curtain wall, hybrid wall. How does it going to behave on the building? How does it interact with the current structure? What could we do to optimize the interior versus exterior? We ultimately landed on a curtain wall approach. And then from there, looking at the market to understand, does it want to be a pressure equalized system, or is it going to be, I would say, more of a traditional Miami wet sealed system, so a barrier wall approach. Looking through different vendors, we ultimately brought in Alpha Cladding, and they have a pressure equalized approach, so more of what I would consider a modern day curtain wall, and they were able to achieve the spans, the anchorage connections, the cantilevers, kind of able to check all the different boxes that the architect wanted and that the client, the building owner, ultimately desired. So, overclad versus reclad, in terms of, we went through kind of all of these different approaches, and we were able to bring Alpha in very early. So it was kind of a pseudo design assist type concept. So this is what the building looked like before, or both buildings. I believe the one on the left is 501, the one on the right is 601. So if you're paid attention on your drive in, it looks completely different today. So you can see it's, a lot of concrete, small openings, and not just kind of the light coming into the building, but also the depth of the existing facade was significant. So one of the key benefits that we kind of went through in feasibility, I think it's here, so is square footage. So by bringing the wall and pushing it out essentially 8 inches from the face, and then taking advantage of the depth of the wall that currently existed, all the red area is pickup in square footage to the interior office space. So they were able to not only gain kind of a Class A type feel to the building from the exterior, there was economic benefits beyond just performance or mechanical systems. It was really significant increase and it actually, in some sense you could say, it funded itself, right? I should say, so part of the job too was all of the terraces. So there's many terraces throughout the building. They don't line up. They're not necessarily symmetrical. And, when we're bringing the curtain wall up, to use the cantilever portion as the rail, redo the terraces, redo the doors, everything was included. The one, I'd say, major element that really didn't get affected, but you don't see it anymore, are the steps on the roof. So there's existing concrete steps on the roof that were part of the initial architectural expression. Now they're essentially abandoned, but there's no need to remove them. They didn't really serve a purpose for the new facade, and they didn't really serve a purpose for the existing building, other than you would have to bear the expense and the aggravation of removing them. So you're able to keep those in place and not have any impact to the roof. So speaking to the availability of the market, so as we know, Miami, hurricanes, impact requirements, high loads, thermal performance, not so, we're a cooling town, not necessarily heating town. So, solar gain coefficients more important than U values, which is why you see kind of the more reflectivity in the glass than you would maybe somewhere else. So part of the whole approach kind of leading from the feasibility into now, early contractor engagement is working with the vendor, in this instance, like I said, Alpha, and through their prime, which was Gricon, and seeing how they wanted to approach. So we know the architect wanted kind of an all glass building, and we know that in order to achieve that, we needed to cover those steps. So that required a cantilever. So that was a big element to the project itself, is being able to achieve the cantilever facade without having to add so much structure. And they were able to do that by way of one-time approvals and mock-up testing. I think our largest cantilever, one's in the crowd, he would know better than me, but I think it was somewhere around 10 feet. So again, just the different items that we went through. So the design assist, the engineering, the mock-up testing, one of the benefits to bringing on a contractor early is you can get essentially shop drawing level details into the architectural set, which helps refine the scope and limit exposure to change orders. It also speeds up the fabrication process, because generally when we're coming out of this, we already have approved shop drawings, at least for dimensions, so they can start fabricating right away. So just some of the nuances. So on the left, there's kind of an elevation of the mock-up. So we did have to do a mock-up for testing for one-time approval. On the right, you can see, there's the sunshade element, which was important to the architectural expression. So we were able to use that by way of essentially an attached extrusion. So it can be, replicated many times over in simple attachment, simple removal. One of the things that's kind of unique about the building is, or the existing structure, was it had a step in the facade. So the face was not flush kind of all the way down. So the anchorage design was important by way of, angles and sled anchors that could be adjusted and modified, so that we could bring the facade kind of flush all the way out and not have any interruptions with the structure without having to demo significant pieces of it. So again, this is kind of early on, working through the different details. So at the roof level, so you see the steps, on the right is kind of an early architectural concept. On the left is advanced detailing from Alpha, and understanding how we needed to close the gap between the backside of the curtain wall and the face of the building and the roof, so we don't get water inside. So incorporation of curbs, metal flashing, additional seals, copings, and this is a significant risk to the building if it's not done right and it's not done in a way that can be maintained. So again, coming out of this design assist, we had kind of the design was done. It was really getting into the details, making sure that the connections and the anchorage was correct. Working through in parallel with this any sort of VE options. So we talked briefly about the steps, leaving the steps and using cantilevers rather than additional structure. While it is probably easier from a facade perspective to have more steel, in this instance it carried a lot of cost and maintenance exposure. So it's beneficial to have it in the facade. Speed this up a little bit. So again, more advancement as the process continued, and this process kind of occurred, I'd say, over 18 months roughly, before kind of we started really getting into the CA or installation. So you can see on the right is a fairly integral part, which is unique. We've had to drain those steps because they all drain out to the building, and there's no existing drains there. So we're able to bring it through the facade in a similar manner to how it was before. Another unique piece to this is because it was two buildings over a common podium, there were expansion joints. So one of the tasks was to relocate the expansion joints, and the other was trying to accommodate the expansion joints. So at the base where the facade meets the lobby arrival level, we actually had to extend the structure to pick up the facade and then replicate kind of call it a false curb underneath to terminate the roof or the waterproofing underneath of the lobby. So really that the storefront is sitting on a cantilevered plate. The other piece to it, which is kind of similar to the antennas, but it occurs at the cantilever piece again, which is kind of a fixed false stack joint there, was being able to accommodate the infrastructure that existed at the building. So there's a lot of cell antennas for different utilities. So those had to all be, they had to remain in place. So they had to be able to bring the structure through the glazing, maintaining a watertight condition and all the functionality that it had before. So kind of the most interesting piece, I think, to this was the install. Like I said earlier, I think while most jobs suffered from COVID, I think this one might have benefited from COVID, primarily because we were recladding an existing building with existing tenants, and trying to do this in with the least interruption to the occupants as possible. With COVID, luckily for us, not for the landlord, occupancy went way down. So you have less aggravated tenants throughout the construction process, throughout the drilling. And it made, I think, ultimately for an easier job from that perspective. The other benefit that, with the curtain wall assembly and maintaining the existing facade in place, doing an overclad, is we really reduced the risk to water infiltration during the process, because none of the interior walls were demoed until the facade was up. So you didn't have zip walls or anything else trying to keep the elements out. So this is just in some kind of photos throughout the process. So one of the things that was done early on, because we had the permit, because we had the time, was they actually went ahead and essentially installed all the anchors. So rather than installing anchors as we progressed, a crew came out in advance and installed the anchors, so that when they were ready to actually start erecting panels, that was done. Kind of another VE measure you can see here on the right is the decorative banding of the tile. So behind it, it was just an adhered tile. It really served no purpose other than aesthetics. So by not having to remove all the tile, you save on demo costs. So we were able to locally remove tile where we needed to have anchors and essentially abandon what was there before. So again, more anchorage before, you don't see any panels. So it's a little bit unusual to have that type of advanced attachments ahead of your glazing, but in this instance, it worked. So part of the challenges obviously on the occupied site is sequencing your materials. So here, this is at the arrival deck. So obviously, it's very, very cluttered. Luckily, not a lot of usage during this time frame. But as kind of we came out of COVID and kind of more occupancy, they had the ability to store the units underneath in the garage. So we were able to take advantage of the times and make it easier for ourselves. So just photos as we go along. So obviously, we start curtain wall. You generally start at the bottom, start wrapping in some dimension around and up. So a lot of corners, a lot of ins and outs. It's a very complicated building in terms of its geometry and all of the terrace work that was going on and additional curbs that needed to be added and supporting structures. So there was many crews out at one time. At first we started, I think it was on 501, which is the smaller building to the south. And as that progressed, they added 601, which is the building to the north. So here you can kind of see, you can get a feel for how much space we're actually picking up. So the photo on the right really shows you can see the face of glass, inside face of mullions around 8 inches, couple inches off, airspace between the two for your fire safing, and then the depth of the assembly itself that was existing was around 1.5 feet. So on the left, you can see kind of what that looks like. So you see the opening for a door that will be in place, or that was there before, in the front of the picture, and then beyond is the new door, the new facade. And so we were able to enclose kind of everything before demoing anything on the inside. The risk to that obviously is damage to the interiors or to the new glass, but they were able to protect it in a way that we didn't have any significant issues during the interior demo. And all they really had to do was extend the interior flooring finish to the facing, and they're done. So you can see on the right, now all of the units were delivered without the sunshades, so just to protect them from damage. But as they progressed with the project, the sunshades got added after the fact, and really, it really is a nice architectural feature to the whole building. Kind of, you can see some more before and after. So the photo on the left is the picture everyone saw driving in, and on the right again, you can see more of the kind of the transformation of the job as it progressed. It was really kind of a pretty impressive project, and unique to the market. This is a market that is generally newer buildings, so there's not, and there's lots of space still. So there's not the same need or desire to repurpose existing buildings in this fashion. In the picture on the right, you can also see, if you remember from the beginning of the slides, there's these 2-story spaces. How do I do this? Up here. So those were actually enclosed. So we had to add additional steel, put decking down, turned it into a floor. But so now there's no steps in the facade. It's continuous. This is just some in progress at the lobby. So this is the area where we have the expansion joint that runs along, right along the face of this, and actually up and back and then up again. So you don't see the whole picture here, but the storefront sits on that cantilevered plate, and we were able to do kind of all of that. And then they kind of wrap the connecting lobby, which you can kind of see here. I think the span is around 23 feet for the glazing, and has curved corners. So it's really an impressive facade. And I should say that the same detail that we applied down here at the storefront with the expansion joint is true where the glazing in the curtain wall sits and meets the canopy structure for both buildings. So that same detail is applicable. That expansion joint kind of wraps around on both sides. So the connecting lobby essentially floats between the two buildings. So this is, you can kind of see on the left side here on the bottom. So you see that curve, that's the expansion joint that extends up and over. Okay. So this is kind of, it's a simple approach. It's a roof built between two buildings, but it's pretty unique. It did have its challenges. It's a light frame structure, so it's all metal decking and steel inside, versus kind of the buildings left and right are very heavy concrete structures. This is not occupiable. It's just you can get up there for maintenance, and the turf is used for aesthetics. So the second part of the job, I'd say a little less exciting, but kind of wraps the whole thing, is the parking deck. So to the north is the parking garage that services both buildings, and it also has kind of this promenade of restaurants and little stores on the quay. So part of the job was to basically open up those storefronts, new glazing, bring it into kind of modern day impact requirements, and then they added some cladding on top of that as well. So again, more of you can kind of see the geometry, how complex it is, and given that it was an existing building, so I think less susceptible to construction tolerances and concrete placement. One of the benefits of the curtain wall assembly and the unitized curtain wall assembly is our ability to kind of set a datum, set a stack joint location, and have it kind of line up, all the way around, despite all the ins and outs. Just more of the finished connecting lobby, 2 buildings. And that's it.
Thank you, Zachary. That was a very interesting deep dive into recladding. Up next, we have Errol Bull from Momentive, and he has over 15 years of experience in in silicone technologies, and he's going to be talking about how modern design and safety standards and silicones, how they can help improve that. So.
Everyone can hear me? Yes, okay. So today we'd like to highlight advantages of a certain product that's the 3rd generation structural silicone. I doubt there's anybody in the audience that doesn't know what structural glazing is, but if there is, just for awareness, it's glass bonding. You're bonding glass to a finished metal in a curtain wall frame. And the first patent for this 2-part technology came out in the 1970s. It was used to bond glass to make IGUs. And within a handful of years, it was adopted into bonding IGUs and monolithic glass to curtain wall frames. So the 2-part technology emerged in the 70s. And we'd like to highlight the advantages of a certain product that's been on the market already for 15 years, but it's the 3rd generation 2-part structural silicone, and kind of show you what it can do. I'll start with a very brief history, 2 or 3 minutes, of how structural silicone glazing emerged, just in case there's some in the audience that aren't aware. Our company is Momentive. It was formerly General Electric Silicones for 70 years. General Electric sold it. These are some of the milestones of this company. I was one of the co-pioneers of the silicone materials. And really, the first patent was filed in 1957 by a French company, Rhone-Poulenc, for a 1-part material pre-mixed in a cartridge that could be dispensed and cured, an RTV silicone sealant. And within a couple of years, 3 companies were selling this silicone sealant technology. And in the 60s, it evolved about this exact same time as the float glass process was commercialized. So this float glass process revolutionized glass. Prior to that was the plate glass process, which required polishing on both sides for distortion-free glass, was very expensive. So it offered architects and designers a new opportunity to have bigger, cheaper, distortion-free glass. So silicone sealants and the float glass process emerged. And these 2 initial trends emerged in the 60s. This thing called butt glazing, where you had a long wall of glass with just a silicone sealant. And also the glass mullion systems emerged as those float glass suppliers were able to make larger, stiffer, stronger pieces of glass. And in the glass mullion and the butt glazing system, naturally, the silicone sealants were used. They're both founded on element number 14, silicon. So it was a natural inherent ability of silicone to bond to glass. And within a few years, it was found in laboratory testing that the silicone rubber didn't degrade with exposure to UV. So it was rapidly adopted into these kind of glass systems. And in the 70s, people started to take glass and just bond it to curtain wall frames, or finished metals, let's call them, whether it was on site or in a factory. So the trends really were, buildings like this were fairly low rise, of course. It was a new technique. Nobody had done this before. People were wondering, hey, is the silicone going to come unstuck and will glass fall off and, harm people? But by the end of the 70s, we had unitizing emerging. People were now doing it in a factory and then sending a complete frame to the building site. But some of the very initial installations were site installed. This one here is 50 years old at this point. It's in Chicago and is still there to this day. Skip past the 80s is really where the technique was globally adopted. The 70s was a cautionary decade, and in the 80s, really became into global use. I don't know why I can't show you the 80s slide. Oh, there it is. This building is here in 800 Brickell. It's been there since 1979. That was the first four-sided structurally glazed, in quotes, high-rise with the use of insulating glass units. And has survived many hurricanes. So the silicone technology, even at that point, could withstand the pressures. And in the 80s, the world trended from that original patented technology from 1957 was acetoxy silicone. It's the kind of silicone that smells like vinegar, to what's called neutral curing silicone. And there was a technical reason for that we can't get into here, but if anybody wants to discuss it later, we can. But those are the trends there on the 1980s. The 1990s continued to see global adoption, and China and Europe advanced their own international standards, whereas in the 70s and 80s, ASTM was the guiding force. So we continue to see taller towers. The 2000s, again, super talls now. You're getting into taller towers. And structural glazing at this point has kind of become the norm. It's not uncommon at all to bond glass. We see the increase in safety and bomb blast mitigated requirements. Of course, the hurricane market that evolved in the 90s. We see triple glazed IG units, more, of course, gas-filled IGs for energy reasons. And more robust silicone formulas started to emerge. So stronger, more capable silicone sealants. And the world at this point had moved predominantly in the built world to two-part silicones, where you're mixing a part A and a part B together for curing speed reasons. So most any of these tall towers are done with two-part silicone. And what I really want to show is the advancements in that two-part technology. Okay, even into the 2010s, we see taller towers still, increasing design pressures and bigger glass. So the formula to calculate how much silicone is needed to resist wind pressure is based on Stephen Timoshenko's theory of plates and shells. And it's a very simple formula, but the bigger the piece of the glass and the bigger the wind pressure, the more silicone you're going to need. Those two numbers are in the numerator of the formula, the glass size and the wind pressure. And the stress allowable in silicone is in the denominator. And we're going to show you an advancement in that as well. So these are three modern day towers, two under construction and one complete, that are all four-side structurally glazed with this two-part silicone that we want to show you. So what were the advancements in this technology? Again, this was the generational history of the two-part structural silicone, not one part. That 1977 first generation two-part used in insulating glass units was adopted in 1980s, early mid-80s, to be used as a structural silicone. And over the decades, it's evolved and been improved, and that's what we'd really like to highlight today. So this new two-part is significantly stronger, so it can support a higher design stress. It has significantly improved adhesion. About 95% of the substrates that you can test will not require a primer. And it's got a significantly improved mechanical profile based on its adhesion, its elasticity and its tear resistance. And we'll show you that a little bit. So first of all, I sit on the ASTM C24 committee. This is my 25th year. C24 is called Building Seals and Sealants. And in 2017, a task group was started to discuss the allowable stress. It was chosen 40 years ago to limit it to 20 pounds per square inch, 20 PSI. But with more capable and robust silicone sealants, there's been debate about increasing that stress, that allowable stress, to 30 PSI. And it's now, after two ballots and some negatives that had to be overcome, it's now in the current ASTM C1401 guide, where some silicone sealants, not all structural silicones, but some, can be used for 30 higher allowable stresses, which essentially means you can use less silicone because the allowable stress is in the denominator. So when you do the math, you get a smaller number, which isn't all that meaningful for the structural silicone, more meaningful probably for the less aluminum you can use on a very tall tower. You can conserve aluminum and weight, foundation size, anything you can extrapolate from a reduced mullion width. First of all, these are 4 competing sealants tested on 50 random substrates after 4 hours and 24 hours without using a primer. And I just wanted to highlight that this latest technology really sticks to everything. It sticks, and it's not only does it stick without primer, but it sticks fast, which is probably more important because the curtain wall fabricators that are building curtain wall frames need to move them out of the way and bring another one in. And if it doesn't stick quickly, then you can use a primer to increase that adhesion speed. So this one really sticks and sticks without primer quickly. It has an improved strength, and the graph here is kind of confusing, but these arrows are showing current two-part technology and the older generation two-part technology. And what you'll notice is the green line is the elasticity at break. So it's a more elastic material. And I'll show you what advantages that brings. The older materials are less elastic. These are properties of tensile strength in blue and elasticity in green of like 11 or 12 competing 1- and 2-part structural silicones sold around the world. I don't know how to get these videos to play. Let's hope it works. Okay, so you're seeing a common 2-part structural silicone on the left, a very common, current, modern 2-part, and the more elastic, higher strength technology on the left. So it's a stronger, more robust silicone. And also in resistance to tearing, I wish I could repeat that video, but let me see if I can go back one slide and try it again. This is without cuts in the rubber. The second video you're going to see is with, you purposely pre-cut the rubber. It's a European test, and it's a resistance to tearing test. You can see the cuts, the silicone on the right ignores the cuts and just pulls to destruction. The silicone on the left will, connect and zipper. It has less resistance to tearing. Why would that be important? It's helpful in seismic, it's helpful in hurricane blast, impact resistance. And here's a couple videos to demonstrate the elasticity and resistance to tearing of this product. That's a 380-pound IG unit where the head, the jamb, and the sill were cut and hinged back, not a full 90 degrees, but probably 70 degrees, and it's withstanding and bending and stretching and holding that. There are no other 2-part silicones that can do that. The second video is the same concept, but just a little closer up so you can see what the rubber looks like. It's able to withstand a full 90-degree bend in a 1/4 inch thickness without tearing or otherwise, losing adhesion. So it's a far more elastic, stronger, and robust tear-resistant silicone rubber. Helpful for bomb blast, hurricane applications, of course. I don't know if this is a video. Okay, this is like a testimonial. This was done in 2012, I think. The metal panel, the edges of the metal panel sheared. It's and came out of its cassette, but the 3 IG units that were structurally glazed, all 4 sides were fully intact without any failure. So this product is capable of resisting blast. This is a hurricane impact design that was tested probably 15 years ago or close to that. It was a project in Hilton Head, South Carolina, or maybe it's North Carolina. I don't remember where that town is, but it was a corner design. Structural silicone went around the corner of the IG unit. And the owner of this company tested it for the project at 52 pounds per square foot for the project design stress or design pressure. And, it took the 3 impacts of the ASTM impact test and a subsequent 9,000 cycles at 52 PSF. That owner then tested the same exact frames again, restruck them 3 more times, and tested it for another 9,000 cycles to 120 pounds per square foot. And he said, I'm done. I certified my system to 120. If you want to do more testing, you're welcome to. So for $900, we cycled it and impacted, tested it 9,000 more cycles at 250 pounds per square foot. So 36,000 cycles of the same impact frame on a corner bead of this 2-part silicone without failure. As a very stiff IG unit, you could see the makeup over there. It's a couple inches thick, laminated glass on both lights. But we also did some pressure cycling, and I asked the test lab if they would pressure cycle 3 frames. I'm just going to show one, up to 50,000 pressure cycles. And I chose loads that would theoretically stress the silicone to 40 pounds per square inch. And they said they'll do this for us, but only 10,000 cycles per day because they didn't want to let it run unattended overnight at these higher pressures. So what you're seeing here is a Monday, a Tuesday, Wednesday, Thursday, Friday. After 30,000 cycles at 40 PSI, I asked them to, on Thursday, do 10,000 cycles at 45. On Friday, 50 PSI, 10,000 cycles at 50 pounds per square inch, where the design stress has traditionally been 20, now 30. 50,000 cycles. And I'll pay you, please, if you'll blow it under negative load to failure. Try to fail the structural silicone. And I'll show the video. I hope. Yeah. So this is after full 50,000 on a 5-foot square frame, 1 inch of structural silicone, 1/4 inch thick, unprimed to an anodized frame. And I called the lab after about 1,140 pounds per square foot. That's an outrageous pressure. And I asked them to not throw the frame out because I wanted to drive up to Montreal. And I cut the entire frame. I'm sorry it's not in the video, but I went around and cut the entire frame. And there's not one single lineal millimeter. It is here. It's too long to see, but I went around the entire frame and there's no failure whatsoever of any of this silicone. So I'm going to cut this short. If anybody doesn't believe me and wants to see it later, we can play it. That's it. Did I buy you some time?
Thank you, Errol.
Yeah.
That was really interesting silicone tech. A lot of good information there. Now, please welcome Rob Harrison. He's a senior partner at Forrest & Partners. He has a portfolio that spans in high-performance sustainable building and envelopes. And he'll guide us through the Aventura Bang facade study. It's about careful study about geometry testing and material choice. Rob, welcome.
Good afternoon, everybody. Can you all hear me okay? Great. Building I'm going to be talking to you about is currently under construction in Aventura. It's one that we started quite a few years ago, back in about 2020, just before COVID. I'm going to be talking to you today about several aspects of it, the geometry studies that we went through initially. Then I'll be talking you through the various different external wall systems that we have. And then I'm going to finish up by talking over the various glass selection and the testing processes that we went through. The site is slap bang in the middle of Aventura, right next door to the Marriott Turnberry Resort and within a stone's throw of the Aventura shopping mall, where we've also designed the Apple store that sits in one corner of that. To take you through the site analysis and what we inherited as the constraints for the plot and for the building, we have the site boundary, the setbacks either 25 or 20 feet from it, the lot size itself, The building height, a maximum of 120 feet, with further setbacks, again, from some of the edges, but with the 40% lot coverage that were allowed and the 120 feet height restriction and a 2 times floor area ratio, we were also limited on 12 stories as the maximum number that we could have. All well and good until you factor in the number of car parking spaces that we had to provide, which was around 360 parking spaces. If we were to place those in the building, and you'll see this is a fairly common motif of the buildings around it, you end up with this situation where a third of the building, a third of the volume of the building would have been taken up with the car parking. I think probably the biggest win we got was persuading our client to go to the not inconsiderable expense of placing the car parking in the lower level. So if we were just to take a portion of that, about half of the parking, place that down in the basement, and then have some surface parking, we'd managed to eliminate the volume of car park or volume of cars that had to be parked in the lower portion. We were fortunate enough to be able to get pretty much all of the cars, 320 of them, into, in the end, 3 levels of basement. And then around that, we have about 60 car parking spaces around the landscape base. We were also able, by having a number of conditions, one of which was achieving LEED Gold for the building, we were able to raise the height of the building up to 200 feet. So we took that conditional use zoning allowance to be able to have a more generous volume for it. As is often the case, if you can get the larger floor plates at the highest point in your building, you're going to be able to lease them for a greater price. The consequence of this always is, well, how on earth do you make the building stand up? It's a lovely diagram. It's not often able to be translated into architectural reality. But nevertheless, it was our client's brief to us. How can I have the maximum size of floors at the highest possible level in my building? So the intention of this kind of pyramidal form of a narrow base and a wider top took form. And I'm going to step you through a number of the variations that we looked at. We looked at about 3 dozen in total, and I've got a few snapshots of various of those along the way. Right at the end, I'll show you the full summary of them, but to take you through just a few of them. This one was not terribly inspiringly nicknamed the K formation for the building. It kind of did what it needed to do. It had a very grand, and this was really the model that applied to all of the schemes. It has this grand entrance lobby at the base, then a series of floor plates which get gradually bigger as they come up. This one we nicknamed the World Cup because it, well, kind of looks a little bit like the World Cup if you squint. That's the World Cup, the football, soccer World Cup. 4-sided but curvilinear in its form, so it really came out of some of the circular forms that we had looked at, a slightly more rationalized one. A further rationalized version of that was where all of the surfaces, the planar surfaces, became angular, so the structural members were straight and the surfaces themselves were planar and flat. This a 6-sided octagonal version, which eventually, through a little bit of further analysis, we got to this model where we were translating from a square up at the top to an 8-sided, slightly eccentric octagon form at the base. And this really then formed the basis of a whole series of studies that were much closer to the final form of the building. But if I just click forward again to really where the main establishment was, we have the building's owners it's a bank, and they have the upper floors of the building. Then there's a series of differently sized floor plates through the middle, and then this generously proportioned lobby space at the bottom. So this then was our final diagrammatic form, and we then went through a number of different variations of how the structure was going to be represented on the building, whether the corners of the shape came out like this into a sharp pointy corner, or whether they were angled and profiled back. So we cycled through a number of different variations, all on a very, very similar theme. But you can see there's slight changes in the height of the entrance lobby. Where did we put that transition point between the inwardly pointing and then the outwardly pointing volumes of the form? And finally, ending up at the version which is very, very close to what is now being constructed, where the lower portions of the building just flare out, and they actually flare out from level 3, which is a floor up above the main entrance lobby. That was an example or a photograph of some of the prints that we did of the schemes, which sit in our office back in London. And prior to agreeing the final form with our client, we produced a series of maquettes that these were all sort of little tiny 1 to 500. I'm afraid I have no idea what that translates into in imperial measurements, but they're about sort of this high. So a whole series of these little models that we took to our client, really for him to decide, and ultimately it was his decision as to which we went to. We were relatively agnostic about which we preferred. We'd kind of fallen in love and could have proposed any of these versions, but ultimately it was down to his choice as to which one he went for. And there is another version, another image of what it's like. So to take you through the external wall systems that we have for it, rendering over on the left-hand side, an intriguing geometrical puzzle. How do we then clad? How did we go about cladding that? And it was through a series of the different external wall systems. As you can see, there's, I don't know, about just over half a dozen of them. I'm going to talk you through 3 of those today in order to ensure I stay within the allotted time. And those comprise the areas of stick-built systems, which are primarily in the lower level, so in the banking hall and in the corners that define the edges of the building, together with the engine room of the building, which is the unitized systems, which cover the upper portions, essentially from level 2 upwards. So starting with the main facade, the EWS 101, or External Wall System 101, which is, I would say, 75 to 80% of the facade is this system. And it's composed of a series of main units, which are the rectangular ones you can see over on the left-hand side. But then in all of the corners, we have our large mega units, which comprise both the rectangular panel and then the triangular piece. Well, actually, it's a trapezium because it's a very, very small flat piece along the bottom there. So it combines those two with a dummy mullion on them, and those come in as these large jumbo units that also unitized and sit in with the main volume of the facade. Because we were restricted to 12 stories, and we wanted to maximize the 200-foot height limit, we do have some very generous floor-to-floor heights. You can see them on the side here. From level 2 up to level 7, we have just over 14.5 feet. Then level 8, 9, and 10 is at over 16 feet. And then the highest floor, which is the client level for the bank, is up to just over 20.5 feet. And then there's an occupiable roof terrace up on the top. So very large glass sizes, which were performance tested. I will talk about the performance tests later, but just to give you an indication of the size of these, this is the upper portion. So that is the glazing unit for level 11, and then that is the upper one for level 12. So that's the 20-foot 7-inch, and that's the 16.5-foot unit that were tested in West Palm, but I'll come to that a little bit later on. Moving on to EWS 104, which is the corner unit. So these are the areas at they line the outside parts of the entrance area and of the main banking hall on the lower portion. Internally, what they do is to expand out the entrance area. So because the building is pinched through, it would have had quite a narrow entrance space and quite a limited entrance space. But what these little trapezium elements do is they just push all of the four corners out to provide us with these internally much more generous waiting spaces, lobby spaces, lounging spaces inside the entrance area. The interesting thing for this slide, but the point that I want to make to you all with this slide, is how you have something which appears relatively straightforward. It appears as though it's fairly seamless as it goes around, but the complexity to achieve it was quite significant. The two different section cuts that you can see over on the very left-hand side, they describe the two of the different surfaces, two of the three different surfaces. And although they appear to be continuous, they are in fact quite distinct from one another. The profile, the internal profile, the internal profile over on that side, and which is all structural steelwork, and then the external portion, which is the aluminium framing for it. They're quite different, geometrically quite different, and how they tie up and how they line through together to give you this seamless approach. That was one of the most complicated challenges that we faced on the project. The spans are also pretty heroic. At the lower level, they're 36 feet, so we have these long span structural beams which were part of the facade system and are currently under installation on site at the moment. We had the design intent for this, that was our team together with TT Facades, was then validated by the contractor, and they went through quite a lengthy validation process to be able to deliver the design intent that we have. This is going to take you then through the sequencing which is on site at the moment. So this is them bringing the various different modules together. An interesting bit, if you can read it okay, is to have a look at the sizes of it. Again, it's in kilograms, so I hope you'll be able to roughly get an idea of what that would be. So we start with the vertical props and the assembly point on the front. Then we bring in these 4.5-ton units, which are filling up the next stages of it. That's then repeated over on this side, and then the whole assembly is propped up. So again, you've got two lots of these 4.5-ton units being brought in. Then the next section, slightly lighter, but still 3.5 tons, installed on top, slight extensions to the vertical, the inclined verticals, replicated over on the other side, and then the remaining portion of the verticals going up. Again, each of these infill vertical pieces that are going from here up to the top, each one of those is about 2 tons. Then there's an intermediate mullion, which comes across just to stabilize the whole of the framing before the other mullions are put in place in order to create these framed corner pieces. And this shows you the different from the webcam that we have on the adjacent building, shows you that installation process. So you can see each one of these steps going up to create the final version there. The reason why it looks a bit bent, is a bit curved, is because it's a very high fisheye effect on the lens. The actual shape of it, which I've got a few photos of later, is much more geometrically accurate. As well as a series of performance tests, quite a number of performance tests, we also had visual mock-ups that were done for the project. Some of them were full-sized ones, well, they were all one-to-one size, but some of them were, a story or two high, and then others were these tabletop, well, they referred to them as tabletop mock-ups, but I think you'd be lucky to find a table that was burly enough to be able to support these. But we had several of these smaller mock-ups that were put together really just to assess the architectural quality of what was being put together, and they've been super successful. We have these on site as reference elements that we can compare against the works as they're progressing. And this is a shot of the same unit, sort of viewing it from underneath. So the two-stage element of the extrusion on the outside, and then the AESS structural steel on the inside. So that dealt with those corner units. I'm now in the last part of describing the external wall systems. I'll talk to you about the main column cladding for the building, our EWS 401 system. We had originally designed this as, well, as a stick-built fabricated system. So we were putting this together as a series of sheets, folded pieces of aluminium that would be brought together on site. Through the value engineering process, the contractor proposed this being a unitized system instead. So it altered the way, it altered joint sizes and other things on it. One of the primary concerns that we had is because the shape of the building, the fact that this profile is actually narrowing as it goes to the top. The structural members get smaller as they go towards the top, and so the whole frame, the external cladding for it, also shrinks, which means that on any one length, there's a difference between the angle at of the one side, the rectangle of one side of this sheet. There's a slight morphing, slight warping of the difference. You can see it on this section here. It's the difference between the red at the bottom and then the black line, which is the upper portion of it. So it translates across one story, you get this translation occurring. We didn't know whether, if they were to simply twist the form, whether we would notice that warping and whether that would be visually discomforting. An obvious way to resolve it, and we've done this on many of our other projects in the past, is simply to introduce a crease. So you're not dealing with a warped panel, you're dealing with two triangles instead. But you will read the crease line, whether it's a concave or a convex crease. So the contractor mocked up both for us, and we decided that we were very comfortable with the warping, the twisted effect. We could see no visual distortion with it because it's relatively modest. The amount of twist is relatively modest. So we decided that we would go for the slightly twisted form. The next thing we looked at and analyzed was how we would light the columns at nighttime. And our original intention was to try to wash the whole of the surface, or wash as much of the surface as we could. But the problem that we had with it was, as soon as you got very acute angle to it, you ended up seeing the light fitting, which it just became too much of a distortion. So we instead removed the position of the light fitting so that it was effectively illuminating the hollow, and you got this glow from the hollow rather than trying to wash across the face of the surface. So that's the difference you can see here between, that's where we're trying to wash the surface, where the light is pooling, spilling directly out. This is where we're angling the light back inside the hollow, so you get just more of a glow there and just some slight bleeding of the light out from the edge. This was the one-to-one visual mock-up that was done for it. It combined a number of different systems, but it was crucial for us to understand how, having moved from a stick system to a unitized system for this, for good cost-saving reasons, it did mean that joints like this were considerably wider than we had designed them in our design intent. And visually, it made much more sense to, instead of having the black gaskets in here, we moved to using this gray gasket instead, which is, it just disguised, from a distance, it just disguised that break between the two elements, which otherwise was a much, much tighter joint during the design intent. But it gave us an opportunity to be able to test these things visually and be able to put forward a solution that we felt was far closer to our design intent. Lastly, I wanted to go through glass selection and then a little bit on testing. We had 7 different glass manufacturers, and in the end, we chose an Interpane sample, the one here, the Interpane Stop-Ray Vision 50. Having looked, and this is actually on the site, it was great to actually see them all on site and to really test them within site conditions where they were going to be placed. But the Interpane sample, it had far less roller wave distortion. It had really great color rendering. When we looked through it, there was very, very little in the way of alteration of the colors. It also, Interpaint were providing an integrated surface service, so they were manufacturing the glass. They were then fabricating the IGUs. They also provided much better warranties for any nickel sulfide occlusions over the first 5 years of the project. So we ended up selecting the Interpaint product. We then had to perform a whole series of different performance mock-ups. Originally, there were far fewer than this, but as we went through the analysis of all the external wall systems, it became clear that because it's entirely bespoke, we had to test all of these areas. So there, in the end, were 7 different performance mock-ups of various different parts of the facade that you saw there, all taking place in either in West Palm, or some of them were done, I think, up in Montreal as well. But it tested all 7 of these areas in order to be able to check for small missile, large missile impact tests. We were testing for air, for wind, for water, and then we were doing the pressure cycling tests on them. So all 7 tests had, or all 7 mock-ups had those 3 tests added to them. And then just to kind of bring all of this to a conclusion, I've got a few photographs of what's happening on site at the moment. So this was from a few days ago, where they're putting those corner pieces in that I showed you on our EWS 104 system. And then this one, taken on site yesterday afternoon, so bang up to date, as kind of close to up to date as I could get, where they've now completed two of the 4 corners, and they're well on the way to the 4th corner. At least structurally, the actual glazing of this is going to take several more months just to complete the lower portion of the building. I mentioned at the start about the various different versions and varieties that we had of this. That is the complete set of the 36 different ones, which you can see they sort of stratify themselves into slightly different families. There are those that are more circular in form. There were ones where actually they were pretty close to what we ended up with, although the actual structural arrangement was different for them. Then there were ones where we were looking at 5-sided, 6-sided, 7- and 8-sided forms. There were the variations of the K structure, which is shown up there on the end, and then there's these slightly more elongated versions. But it was a lot of fun for us just to test different forms. We did prints of a whole number of these, and again, having those in your hand, looking at them, exploring whether you think they really fit and work correctly with the surroundings. That was an awful lot of fun. And then just finally, those are the different glass panels that we had. So the glass selection process, then the visual mock-ups that we did, and then finally the performance mock-ups that were done for it. If you're going past Aventura, it's a fairly prominent site there now. So you'll see the shape of the building now. If you get a little bit closer to it, you'll see what's happening on the lower levels, where those EWS 104 framing members are all going in, and over the course of the next few months, really through to the end of the summer, you'll see the glazing go on, and you'll see the external fins being placed on it. And then the main glazing, the main external wall 101 system starts to glaze the rest, and that should hopefully be completed towards the early part of next year. Thank you very much for your time today.
Thanks, Rob, for that
Pleasure.
refined
Thank you.
look of facade performance. Thank you.
Thanks.
Next, we have a panel discussion. It's on biophilic design and tropical climates. It's going to be moderated by Erica Duran of WSP. She's a recognized leader in sustainable design, and this session features experts from Shinju Bond Architects and Kimley Horn. Please welcome the panel. It'll take us a minute or two to get set up. And after this, we're going to have lunch.
Good afternoon, everybody. Is it a little loud? We're good? All right. Welcome. Welcome this afternoon. I'm your moderator today. My name's Erica Duran. I'm with WSP. We have some great speakers for you today. We're going to run through a couple of presentations. Dean's going to kick it off, followed by Matt. And then I'm going to do a little cameo at the end. And then I'm going to have some fun questions for our panelists today. We're covering biophilic facades, and it should be a really nice, warm, and welcoming discussion. We welcome questions at the end. So just to kind of warm up our panel, I'm going to give them a little softball question to start off. Well, first, what's your name? What's your organization? And then where's your favorite city that you've traveled to? So, Dean, can you kick it off?
Hi everyone. Really pleasure to be here with all of you. My name is Dean Maltz. I'm a partner of Shigeru Architects. My office is in New York City. My favorite city.
It could be city or place. It's okay if you have a place.
Well, I think my first favorite city is the city that I chose to work and live in, New York City. But I would say second favorite city is Miami. I think it's a second home for many people from New York that transplant between, or travel between New York and Miami.
Nice. That's a good answer. So, Matt.
Matt Wisniewski with Kimley Horn, Senior Landscape Architect. For me, it's pretty easy. San Diego. It's where I fell in love, so I'm a romantic, sorry.
Nice. Well, I'll go ahead and answer myself. My favorite city is Belo Horizonte. It's a city in the great state of Minas Gerais in Brazil. And I like it because it reminds me of Miami. So I think I chose a good place to live in.
That's a good reason.
So, yeah, go for it.
Okay. Well, first I want to thank Zak World of Façades for this opportunity to present to you today. I'm going to be speaking about biophilic facades. So let's get started. Does anyone in the audience know what a biophilic facade is? I didn't know what it was actually before the session. I was asked to speak on it. However, I realized there's biophilia in many facades, some more than others. Does anyone know what biophilic design is? Okay, well, for those who don't know what biophilic design is, you should know that it originated with a Harvard professor, Edward O. Wilson, with this concept of biophilia. It suggests that humans have an innate affinity for nature and the natural world, and our interactions with it can positively impact our physical and mental health. So what are these positive impacts? Well, biophilia promotes health and well-being by improving our circadian rhythm, improving healing, lowering stress, promoting socialization, enhancing relaxation, and improving childhood development. So these are all really good things. And here are two high-rise buildings built at two different periods, 50 years apart. A show of hands of anyone in the audience that think the building on the left is more biophilic. Okay, anyone who thinks the building on the right's more biophilic? Show of hands. Well, we got a few more hands. And for those who raised their hands, for the one on the right, yes, that's more biophilic, and perhaps we would think that because of the plants, but there's more to biophilia than just plants. The building on the left is the famous Seagram's building, a commercial building in New York City. And the building on the right is a residential high-rise called Bosco Verticale. The biophilic design is a design approach that aims to create a stronger connection between humans and nature in the built environment. It incorporates natural elements, patterns, and processes into buildings and landscapes to promote well-being, productivity, and a sense of connection to the natural world. And you can see biophilia in architecture when you see the incorporation of plants, natural light, natural materials, water features, natural ventilation, views, organic shapes and forms, and community spaces. And by having these elements, we connect people to the environment, we enhance relationships, and we build communities, and it makes us healthier and happier. So I would think generally biophilia is a great concept. So at Shigeru Ban Architects, our love of nature is reflected in our projects, and in particular, this particular building, Hanagi Forest Apartment, where my Japanese partner Shigeru Ban lives. And without cutting down a single tree, 11 duplex apartments were built around tree-filled courtyards. So following this slide, I'm going to present you with 6 examples of Shigeru Ban biophilic facades, including our most current project in the city of Miami, housed by Shigeru Ban. So this is our museum, Centre Pompidou Metz. It sits under an 86,000 square foot hexagonal mass timber grid shell roof inspired by a Chinese hat. The museum lobby offers expansive views to a nearby park viewed through operable shutters that lend in cool breezes on nice weather days. This 30,000 square foot residential condominium in New York City has operable rolling shutters and a bifold door that open and closes to make an ever-changing facade. And when this bifold door is open, the living room becomes an extension of the terrace. The large glass opening brings abundant natural light, city views, and occasional bird or two. I'm just kidding about the bird. Here, Tamedia headquarters in Zurich, Switzerland applies the metal shutter house concept of the outside room to a commercial application. An occupiable double facade acts as a thermal buffer in the winter, and in the summer, it's a place for outdoor gathering to take advantage of views, natural breezes. The outer wall, with its retractable glass shutter, makes for pleasant indoor-outdoor space when open. Here, the Aspen Art Museum has a biophilic facade in its use of natural material. The grand staircase behind the interwoven wood lattice facade enables visitors to climb to the roof terrace, defined by a triangular wood truss, enabling this fantastic view of the nearby ski mountain Ajax. And the Tainan Museum in Taiwan has a fractal geometry roof in the shape of a pentagon. The shape of the roof is inspired by the royal poinciana, which is the official flower of the city of Tainan. The roof covers 5-story of stacked volumes containing 16 exhibition spaces. The semi-outdoor platform and terraces incorporate green roofs and planted outdoor gardens. The fractal geometry roof, inspired by nature, functions to cool the building by 15% as compared to a traditional flat roof. And this can be seen on the lower right-hand side, the diagrams that talk about the flat roof versus the fractal roof, which creates the cooling. So that brings us now to our most recent project under development in Miami, housed by Shigeru Ban. We're working together with Yakel Capital, the developer, and ODP, our executive architect. And from the very beginning, the developer was inspired to build Miami's most sustainable and biophilic residential condominium. This 12-story mixed-use building has ground floor retail, podium parking, and 320 residential units. The building takes up an entire city block. There are 2 cross-block retail passages that enable the public to enter the building. The entry is defined by the gable that creates the image of the house. From this bird's eye view, we can see the terraces and balconies stepping up from the street and the retail passages. This stepping allows for more light to enter into the apartments and the public spaces. The facade is made of Prodema, a fire-rated wood veneer panel, same material we used for the Aspen Art Museum. And each residential unit with its terrace and balconies are designed as boxes that move in and out across the facade. This view shows a fourth floor garden at the middle of the building. A bridge connects the rooftop amenity spaces. And at the very top, we could see a photovoltaic trellis that provides 20% of the building's energy needs while also providing shading. Another bird's eye view that looks south towards the city of Miami. Lush greenery and planter boxes are on all the terraces and balconies. Plants improve the environment by improving the air quality while also creating a visual appeal. And plants promote health, well-being, and tranquility. And here we could see the extent of the photovoltaic trellis that covered the entire rooftop. And just below the PVs are the rooftop amenities. The roof plan gives us an overall view of the extent of the numerous gardens and plants that are distributed throughout the building on all levels. Ground floor plants bring greenery to the facade and to the street and to the retail passage. There are many benefits to this greenery. Gardens improve human-to-human interaction. Tree canopy covers, lowers the ground temperature, and plants augment storm water management by slowing down the rate of flow through its absorption. And in this building section, we summarize the biophilic elements placed in, out, and around the building. We have developed biophilic design and facade through an enhanced connection to nature, bio-based natural construction materials, rooftop edible garden, water features, and a central garden that promote cooling through evaporation, PV roof trellis for shading and thermal comfort. We have planted terraces and balconies that promote outdoor living, socialization and relaxation, and large operable doors and windows that provide views out and, when open, provide natural ventilation. So that brings me to the end, and I hope you have a better understanding of biophilia, biophilic design, and biophilic facades. Thank you.
So as the landscape architect on the panel, I'm hoping to give a perspective on green facades that's more landscape oriented, and hoping to tease out a couple things over the course of the presentation through two projects. What are we connecting to? How do we make those connections, and technically and also experientially? And then who do we connect with? So here we are in South Florida, beautiful mangrove shorelines and a landscape that's equal parts water and land. And taking that scale of the ecosystem and translating that down into something more intimate that we can connect to. How do we excite imagination through design and take something that's very broad as an idea and make it more personal? So the first project I want to present is Monad Terrace, which is on Miami Beach, west of Alton Road. It backs up onto Biscayne Bay. This site here is looking west. This is the final product of the project, which I'll talk through and show some images under construction. But you can see here the garden that you're met with as an arrival and departure sequence to the building is actually over structure. So the site is bound on the north and south by other residential buildings. This is a luxury residential building. And what you can't see, but you will in the other images, is that both the north and south facade also have a significant green component. This is the arrival up a slow undulating wood ramp. The garden you're seeing in front of you is all over structure. So the soil depths and loading was carefully calculated in order to provide an environment where we can plant both natives and then also some really horticultural and botanically rich specimens to really make the garden a little bit more special. And here, you know, the purpose of today really is to talk about the green facade on the building. You can see what we developed is really a kit of parts that would be a series of planters and wire mesh screening. Working with the architect, this is the elevation. And it creates a really beautiful tapestry that helps the building from a cooling perspective and also from a wellness perspective for the residential balconies. There's a lot of technical considerations when you're working in an area with a dynamic weather system like Miami. Salt spray from the Biscayne Bay, high winds, high solar exposure, all these things really have to be taken into account. And what we developed was a system of planters that has a particular soil mix in it with drip irrigation. And what we did is we launched a series of different types of vines. So we had, again, a kit of parts that could be kind of utilized on demand for the project. This is during construction. You can get a sense of the planters that occur at each level. So there's redundancy there in terms of allowing the plant material to have adequate access to cover the facade. And then we used tillandsias and epiphytic plants, as you can see in the image there, and attached those to the screening for some more immediate coverage. And we also looked at a number of different species of vines and plant material that had different attributes as far as how quickly it could colonize the green facade and which ones would be a little bit more permanent. And so having that expectation met from a large kind of macro view and coupling that with the day-to-day intimacy of the residents that would come and experience these planters, we were able to, again, use a number of different species to utilize depending on where the location was best serving. This is looking out towards the bay, west. And then the other part of this, again, is the garden over structure. So in the back of the building, that's a view out to the Biscayne Bay, and the architect really wanted to have a beautiful kind of water moment that connected visually the site to the bay. And one of the key considerations here was the intentionality of the plant material. So that's a bald cypress tree, Taxodium distichum. We harvested that, looking at the branching structure and understanding what it took to get that down the road and craned into place, and that would transplant well. And we chose that because it's got a beautiful buttress root system to it that will develop over time, and it's got a semi-deciduous to deciduous type of foliage in the winter that really allows kind of visual porousness throughout the site. We also coupled that with coconuts, character coconuts, and these are all hand-selected. We went out there with a client and picked each one, and they really provide some animation and movement to the composition. And then, again, the intentionality of thinking about all the different viewpoints from above and also on-site, really manipulating the plant material in a way that it was site-selected and implemented accordingly thereafter. A view from above, from the building looking down. It's got a kind of beautiful, quiet poetry to it. And then this is one of my favorite images of us out in the field with a client and the contractor picking out the gumbo limbo trees that make the right-of-way elevation. And again, looking at very specific branching patterns and how those materials can interact. The planting plan is all over structure, as I mentioned, so that's what you're seeing here. And again, we used primarily native materials to keep the budget considerations friendly, but also then in key areas utilize some more botanically rich and expensive materials to really create that entry and departure sequence. That's the final product. And then 545 Wynn, which is in Wynwood. Everybody's probably familiar with Wynwood. It's very art dominant. It's a very more urbane condition. And so this idea about who we connect with in the larger community is also something that I think with biophilic design is important to consider. So Gensler was the architect. They incorporated a lot of beautiful artwork throughout the whole building, and the scope of work was the ground floor as well as the amenity deck, which you're seeing a view from above here. We terraced this deck in a number of ways, both to deal with weight in the deck and planting areas so that we can accommodate that, but also to break down the space and provide some really nice opportunities to make the space feel larger with different uses. Soil was something that was a big consideration here, the soil depths and the loading. So what we ended up doing is we used 2 different soil mixes throughout the project, and we backed those off from the larger material where we needed the more sandy mix to create the ballast that's necessary to keep those trees anchored over time with a more lightweight soil. And this is a final view looking from the lounge, that indoor-outdoor connection that Dean alluded to, onto the terrace.
All right, so I'm going to do a quick kind of review of how we can support, thoughtful characters like Dean and Matt in their integration of biophilic design through studies, kind of supporting this high-performance design concept. And the example I'm going to use is the Seattle spheres. So if you've been to Seattle, this is kind of known for an Amazon workplace. It's not just for plants to hang out; it's also for people to work. And so, there's a lot of considerations because the plants don't necessarily love the same environmental constraints that people do. So when you're designing those types of spaces, the spaces that are biophilic in nature, you need to have all those considerations in mind. So how we support designers is we can do building energy consulting, passive design analysis, energy modeling, CFD, computational fluid dynamic studies, daylight and glare studies as well, so that Dean and Matt can know where to put their plants or enhance or change the design accordingly. So here's some of the studies. I mean, it's not super plant-centric the way that you see it, but you can look at the light levels throughout the year. So I can talk to Matt and say, hey, you got a lot of light happening in April through August, but you might want to consider that September and December are going to be very low in lighting levels, and so you might want to consider relocating those plants. You also want to understand the kind of micro environment. So specifically in Seattle, you see the amount of light that is available as well as the cloud cover. So when you see the darker patches in the graph to the right, that means there's a lot more cloud cover, and so there's going to be less sun exposure for your plants. And then finally, this is a cool study that we did in terms of air movement and computational fluid dynamic study, where we could show where the air was going, what the temperature was going to look like in those spheres at different times of the day and throughout the year. So again, you can make a more informed decision in terms of design. So these are supporting services that we can provide for developing a biophilic design and integrating that into your projects. So with that, I'm going to close out the presentation portion, and I'm going to invite my panelists back up onto the stage for some conversation. So welcome back. Thank you again. All right, so we talked a little bit about biophilia and what that means. And when Dean first asked the question, does anybody know what biophilia is? A few hands went up, maybe people were a little shy. But fundamentally, it's a connection to nature. It's that innate connection that we have to be among plants or listening to water, feeling the environment around us and feeling that kind of, it's almost primal, I would say, that feeling. So my first question to my panelists is going to be, how did you get involved with biophilic design? And in your experience, what has been the trajectory of this type of design? Because, we can talk about the Hanging Gardens of Babylon. That was, ages ago. So it's not new.
Yes.
It's almost like a feeling. So go ahead, Dean.
Sure. Just want to mention, if there's anything to remember at the end of our presentation, is just what biophilia is. And I learned about this 5 years ago. I learned it as a new term, and realized that biophilia is an expression sustainability. So it used to be, I used to talk about our architecture in terms of sustainability, but biophilia is an aspect of sustainability. It's a human sustainability, and if there's anything to remember, just the word biophilia to remember it. Bio is life, and philia is the adoration or love of life. So essentially, it's a term that got started back in the 70s, and it's something that's just emerging more today. So I would say, in a certain way, biophilia is the next trend, after sustainability. And how I, sort of got started with it was, it just comes from a natural sense of what great architecture is. I mean, if you think about places that you like to be, it's these places that are inspiring and bring us a stronger connection to nature, and we just feel happier in these places. I'll pass it to Matt.
Thank you. For me, biophilia is really kind of what landscape architects do generally. So in some regards, it's more of a name or I guess an awareness vehicle to really have that conversation with our clients and with society as far as how we live and the quality of life that we want to achieve from a design perspective. And so I think where it presents itself probably more definitively, right, in our practices on the use of its application to architecture in green facades. And as technology has transformed architecture, so too have the opportunities by which we can, utilize landscape architecture in concert with, fantastic architects, right, to create spaces that really imbue a wellness to society.
So I sort of wanted to add to that in terms of, I was trying to explain there are different aspects of biophilia or biophilic elements within the facade. I had to think about that because initially we think of biophilia in terms of, plant material. One of the things that I had mentioned in an earlier slide was this, it provides greater relaxation. And one of the things they speak about with biophilia is this Heraclitus motion. He was a philosopher, Greek philosopher, and he was just talking about the natural rhythms and flows of life. And when you think about that, it's like when you're on the beach and you hear the waves lapping up, and that sense of relaxation. And if you think about the two slides I showed, right, the Seagram's building on one side, and then you saw the residential building on the other. The fact that there are plants that are on those balconies means that when you're out on the balcony or looking through the window, if the wind is blowing, you get to see the movement of the plants. That's a Heraclitus motion, which gives that signal or sense of relaxation. So that's the plant material is a very important feature for biophilia.
Right. Yeah, and there's different types of biophilic interventions that you can have, right? It doesn't necessarily mean it's plant material. There's also low cost and kind of no cost interventions as well. Something that I see a lot of in Shigeru Ban's architecture is those repeating patterns and that kind of consistency that is alluding to patterns that you see in nature.
That's right. I mean, like the museum I showed in Tainan that was with the fractal geometry roof, inspired by the Poinciana plant. When you see forms that are, amorphic, flowing, curvilinear, that gives you, these are forms that we see in nature. And then the project we saw that Matt showed, Wynn project, that the Gensler project with the art, even that art, it provides a sense of biophilia.
I would add also just that, it's important as designers not to have a a preconceived notion about what something should be, and really to allow the design process and the site to kind of express itself. And plants aren't always the best solution. So on Monad Terrace, it was very effective to use water to connect to the larger Biscayne Bay and to be cognizant of all the shadows that would happen within that large kind of courtyard space. So, that's where, sometimes I think as designers it's good just to work collaboratively with architects, because there may be, any number of architectural solutions that are more appropriate. And I think we just have to be honest with our clients and with ourselves to be able to have that conversation.
Great. So, do we have people in the crowd that are from Florida? Raise a hand if you're from Florida. Okay. I grew up in Miami, and I also grew up going to Disney a lot. And if you recall, if you've ever been to Disney, you recall the ride, The Pirates of the Caribbean. And if I close my eyes, I can smell what that ride starts off with. I can hear the music, and I can feel the sensations. And before you take that first dip and you start on the ride. So with that example in mind, when you design a biophilic space, what is your thought process? Do you try to create an experience for the user, for the inhabitant?
When we start designing, we start with the site, and we look for design concept, and quite often that's looking to the context for which we're building in, and that creates inspiration for us. And the integration of these aspects of biophilia, I think, just come natural to us as architects. Things that we want to imbue within the architecture in order to create delight and comfort and beautiful spaces. I also wanted to sort of add, for people who are developers or starting a project, biophilia, it's not something that sort of gets added at the end. I think Matt could speak to this. And there's a lot of planning that goes into it, and you have to think about these elements, whether it's a water feature, whether it's going to be plants, or whether, in a very simple way, do I want my windows to open or close, right? Commercial buildings, they typically don't open. Maybe instead we create internal courtyards, or, where we could have light and air, or when we design a building, we want to create a view corridor, to sort of relate us to the environment. So these are things that we think about as architects as we begin a project, and then we have to then work with our engineers, structural, mechanical, in order to design these elements within the project.
Yeah, I would agree with that. I think that it's a lot of planning up front and good communication with your clients as far as what it takes to actually achieve some of those images that we shared. You need to put the parameters in place to be successful, I like to say, and that starts in schematic design and having conversations and really understanding technically what it takes to, how much does a soil weigh per cubic foot fully saturated. That's something that is going to affect the pounds per square foot on the slab. It's something that is going to affect loading. So, you need the depths of soil, and you need to have strategies and careful conversations with your clients so they know what they're buying. Because for us as landscape architects, we're always at the tail end of the project, right? So if you haven't done that due diligence, you will get VE'd very easily. And to your point or question about experience, we're always creating experience, and I think it's important to remember that whether that's intentional or unintentional, there will be an experience. So why not be intentional about it? Why not consider, who that experience is for and the spaces you're creating? Because, one thing that's nice about gardens is they grow over time. So you have to think about that longevity of the space as well.
Interesting. So, we've talked a little bit about, the kind of softer and intuitive aspects of biophilia, but I'm going to invite both of you to speak a little bit to the stormwater benefits or other improvements that biophilic design can improve from a regulatory standpoint in the context, in Miami context. So if you can start, I'll kick that off to Matt.
Sure. From a stormwater standpoint, I think that, you know, whether it's an amenity deck, a green roof, or a biophilic facade, which has, you know, green planters associated with it, there's a couple things that it does to benefit the environment. It slows down the movement of water, and it gives it that capture time to get into the aquifer in a more reasonable manner. It's not really point loaded at that point. And by doing so, it allows the water to be pre-treated, take some of the chemicals that might be associated with runoff out of the water. A lot of times on our jobs, we actually will drain the hardscape of the amenity decks different than we will the planters because of the different pollutants or chemicals that could be used in either scenario. And we use geotextiles that have some remedial properties before that water actually leaves the planters or hardscape areas. And that helps us and our engineers really manage water in a way that's effective, so not everything's going to sanitary or storm. They can be kind of dialed out, and that helps the client because it saves money on the bill. So there's things that are kind of inherent about the regulatory process, and there's things that are just good practices that we like to see on the projects.
Sort of, I think Matt pretty much summed it up, but one of the other benefits is, other than just slowing down the water flow into the system, is that as it goes through the soils, it actually works as a purification, so that it will then take out some of the impurities, so that the stormwater, which is coming down and washing away the dirts that will accumulate on the building facade, could get absorbed into the biomaterial before then the water then goes into the wastewater system. It's just another benefit of having biophilic planters within a building. And you know, just when we think of starting a building, Erica would talk about how we sort of plan buildings. I think we have to think about biophilic elements as part of the budget, just like we think about other building systems, right? Which is, you know, foundation, structure, facade, windows. You know, having a room and a budget, you know, for these elements, which should be considered at the very beginning. And you know, I think one of the benefits of including these within our projects early on, that it also provides a better project that more people are going to want to enjoy, could add greater value to the property. It's going to be the properties that people are going to want to go to. So it's definitely a net added quality to add to a project.
And so if you want to integrate biophilic design into your project, how does a team ensure that the biophilic design is, you know, there? It's not VE'd out, and it's definitely going to be included. You know, how do you kind of connect with a client to kind of ensure that? Is there conversations that you have at the onset, and is there some sort of kind of ushering of the client in that aspect?
You know, anyone who's ever worked on development of a project or any project knows that value engineering takes place. It's a matter of priorities, and I think clients that want to create biophilic environments will find at least some place to have biophilia. And again, it doesn't have to be expensive. It could just be the way you might create patterns within a building or painting a facade. It doesn't have to be costly. So I think it's a matter of desire, and there are always cost solutions to meet any budget.
Yeah, and what I would add is I think that's good. It is about kind of that hierarchy and finding out what are the important elements that drive the design concept, And so, some things tend to be sacrificial, but if there is a strong, compelling design rationale that's been worked in, then to Dean's point, it may present itself in a number of different ways. If you want to stay true to more of the green approach, what I always advise my clients is to, get unit bids from the contractors, get the clarifications and assumptions, include me on those VE discussions, because that gives us as a window, as a consultant, an opportunity to help keep our contractors accountable, make sure that they're bidding the right materials, and having conversations about how we can VE kind of self-imposed versus relying on somebody to take a broad brush to our painting. So I think that, those are the things that I recommend to my clients. And
So for example, that bald cypress, was that a persuasive conversation that you had to have with the client, or how did that
So it's interesting, you learn over time how to weave your aspirations in with code, right? So tree mitigation on that site was something that needed to be made up. And so, the canopy restoration, the DBH, or the diameter breast height of the material, that's something that goes into the mitigation for the site. So if you can articulate to your client that, these code requirements are there for a reason, but they don't have to be a code minimum project. We can take those and transform them, right, creatively into something that's beautiful, that both, hits, the needs of the city, but really starts to create a space. I think that's a good opening to the conversation. And then once they see the value of that, if you have to go beyond that, right? Well, this is beautiful. We only need a 10-inch caliper tree here, but man, what if I had a 14-inch and it only cost you another $5,000? Would you be open to that, right? So I think it's approaching the topic, through understanding your audience and what's important to the bottom line.
Gotcha. Okay, well, we're getting close to our time, and I wanted to leave a couple of minutes for audience questions. So if there are any, I'd love to see any hands come up. Oop, sir. Oh, we have a microphone for you.
I can hear you. It's okay.
Yeah, you.
Can you hear me now?
Yes, sir.
Loud and clear. The building that you showed in Miami with the box-type balconies.
Mm-hmm.
Now, when you say select plants for that, now I know the plants are going to grow. They may seasonally die, or may require trimming or whatever. So, what is the selection criteria for that kind of plants? Because so that you can minimize the maintenance. Because one thing, the condo owners or the people who live in condo, the maintenance cost is very high. On top, if you now add maintenance of this, that's another thing. So, and one more thing, every building goes through a painting cycle and a repair cycle. Mm-hmm. So at a time you have to have a scaffold up, swing stages up. How does that affect your selection of plants?
Yeah, so just to repeat the question, what I heard was a question about the maintenance costs of that material in the selection process. So I think that, when we're talking about a project like that, that really employs biophilic design at such a level, those are conversations that we have early with the client, and their understanding that, there will be a crew out there more often, and those are conversations that go just beyond the pragmatics of how to take care of the material, but how does that affect the quality of life for the residents, right? To get a maintenance contractor on that balcony, once a week for the first so many months, and then, that can kind of tail off as things establish. So it's a broader question, but what I would say in terms of plant material is that ultimately, the expenditure to do that, it has to be successful, right? It has to be green, it has to look good. So what are the clever things we can do as landscape architects, right, to ensure that happens? Well, the first thing I can do is make sure that I look in the mirror and say I'm not perfect, right? So something will fail. So how can I build a redundancy into my plant palette, or choose plant material that has, the ability to kind of adapt to sun and shade or different water requirements? Things go wrong. So, whether it's one character of plants, right, for multiple jobs, or whether it's a whole cast of characters of different plant materials that have similar foliage but have different light requirements. That's kind of how we approach it, and we also take our cues from nature. So the best way is to allow nature to kind of win. It will grow where it wants to grow. So if we can have a kit of parts in a way that we know, that the cascading plants are going to cascade, the twining vines are going to cover the mesh. The epiphytic plants are going to kind of stay where we put them. So we kind of employed a strategy that way where we looked at like each piece and kind of position that, but then let it kind of evolve. So that's the best way I can answer that, I think, as far as.
Thank you.
Yeah.
Did you want to add anything, Dean?
I think Matt answered it pretty well, but one of the things that we're thinking about for House by Shigar Bond, we were considering with regard to your question about maintenance, whether you want to have built-in into the balustrade or into the roof versus having planter. So we were debating the two, and in house we're looking for all the terraces and balconies, we're considering the use of a planter which can be theoretically moved or relocated, so it would allow for maintenance of the building. I think it's really important that we think about buildings not just for today, but how they're going to, survive, for decades to come.
One other thing I wanted to mention is just those epiphytic plants get their nutrients from the air, from the water in the air. So there's also, again, really understanding the environment and employing plants that can be successful in a pretty extreme environment. So,
Thank you.
Well, we're at time, but I invite you all to come up to us, and if you have further questions, start a conversation. We're going to go into lunch right now. And so thank you so much for having us and for staying put while hungry. Thank you. Thank you to my panelists.
Yes, thank you, panelists, for this vital discussion. It was very informative and eye-opening. So now we're going to take a break for lunch. Enjoy, and we'll be reconnecting in about 45 minutes or so. Good afternoon, everybody. Welcome back. Hope you guys enjoyed lunch. So we're going to start the last session of the day. So it's going to be one of my favorite topics here. We're going to be talking about facade design in hurricane-prone regions. Here to present is Manuel Morales and Cristina Moreno. And they're going to be talking about how building code constraints can still spark creative solutions.
Thank you. Okay, good afternoon, everybody. I hope you had a good lunch. Our presentation is on innovative facade design in hurricane-prone regions. My name is Cristina Moreno. I am the Vice President of Facade and Envelope, and I have over 10 years of experience now in building envelope consulting, inspections, and testing. With me is Manuel Morales. He is the Principal of Facade and Envelope, and obviously much older than me. He has no hair. So he has over 20 years of experience. What are we going to talk about today? So today we're going to talk about some existing trends we have in Florida, some existing trends outside of Florida, applicable codes and standards, some product approval requirements, design considerations, design tools, and we'll throw in some sample projects in there to keep you entertained. So what are we seeing in Florida? In Florida, we're really seeing that the design of the buildings is limited to what has already a valid product approval. This really limits the architect's creativity that he can do for the facade or she. And it really limits you to what's off the shelf already, essentially. And really that's instilled by this fear that a developer or an architect might have here in Florida, that it's very costly or time prohibitive to test a facade or test a new system. And in turn, that really turns into, it's awarded to the lowest bidder that you might have, and they all have similar already tested approvals. These are a few examples of what you might see in Florida. If you notice, they're all similar. They're all about 4 feet in width. Their mullions are similar in dimension. Really, other than the color, they're all very, very similar. What are we seeing outside of Florida? Outside of Florida, we're seeing things that are, they're larger glass sizes and widths and in heights. We've seen a few of them throughout the day today. You'll see more innovative designs that you can see. It's really understood when you do a higher building, a higher rise building, that testing is going to be needed. It's part of the project specifications. And it really just, it gives back the creativity to the architect and the facade consultant, and they really can pre-design their projects and make them unique.
So where does it all begin? Obviously, it's going to start with a design parameter, and the building codes are going to give us that. But today we're going to try and really quickly compare the IBC 2021 to the Florida Building Code 2023. We threw in the wind load parameters from ASE 7. Out of all of these, a really important document for everybody here is the AMA 101. That's the second one at the top. It's what the codes are going to reference as far as required testing. These are not consultant recommended, kind of pet peeves. These are code required testing for glazing systems. And it really peels back the onion on where it all comes from that you'll see in the codes. And obviously you have the aluminum design for mullions, steel for reinforcing. The Ghana glazing manual, not referenced in the codes, but a very useful tool for all the glass manufacturers and the designers. Like Cristina said, we're going to throw in a few sample projects in between. We're not going to leave it all to the end. Most of these projects you'll see here, the products didn't exist before these. And by didn't exist, I mean they didn't exist in an impact-rated form, hurricane, large missile impact. So this one in particular, if you'll notice, they're 18-foot tall, single-span glass mullions with point-supported exterior panels, large missile impact, 88 PSF, and again, first of its kind, I think still more or less one of its kind in this particular project. One thing to notice in the prior slide is, and it's going to be a common theme for all of these, it's if you want to learn something today, is start early. Some people talked about a design process of about 2 years. If you know 2 years ahead of time that you want to design something that's out of the ordinary, not off the shelf, you have time. You have 2 years to decide and then to design and to test and to get the product approval. So that's going to be the running theme today. Quick copyright notices. A few of the slides we're going to show next are printed with permission directly from the building codes from the International Code Council. You or me?
You.
So real quickly, protection of openings. This is not a Florida thing. This is coming directly from ASE 7 for hurricane-prone regions. It says windborne debris regions, and we'll see the definition of windborne debris regions in a second, must comply with the impact protection of ASTM E 1996. And then you'll see in Chapter 17, you've got AMA 101 there. That very long line is basically AMA 101. And it says the windows sliding glass doors and other products shall be tested and labeled as conforming to AMA 101. Still me?
I have to tell him which one's his.
Thank you.
Yes, it's still yours.
Okay, perfect. So the scope, this is important for, the last slide we saw was the 2021 IBC, not Florida at all. This is now Florida Building Code, and if you look at pretty much the first paragraph of every chapter in the Florida Building Code, they're going to say this whole thing applies to the Florida, right? Then they'll say exception, and they'll talk about the high velocity hurricane zone. I assume 50% of the people here know what high velocity hurricane zone is. A few might not, so Cristina will surprise you with what that is later. But notice the two different exceptions. When I look at Chapter 16, which is structural, except buildings in the high velocity hurricane zone, basically shall skip everything in this code or in this chapter and jump to these sections. But then for glass, it says buildings, again, in the high velocity hurricane zone shall include everything in this chapter and add the following sections. So you have to be careful. This is why we ask clients, what code are you permitting your project to? Because these things change from one code addition to the next.
Still you.
Great. Now, still in the 2023 building code, not the high velocity hurricane zone, we still see AMA 101 for both sections of 1709.5, but now we see that they added an optional TAS 202 in lieu of the original AMA 101, except that, again, for the high velocity hurricane zone, they say the only thing we accept is TAS, or Testing Application Standard 202. These are the standards that came out after Hurricane Andrew and what everybody's used to seeing, TAS 202, 1994. Another quick sample project, probably all of you are familiar with this one. Everything you see here is a brand new product. None of these existed before as impact rated products. The top left, actually most of the top line there, these were needed for for very good sound attenuation. These are auditoriums, but also they had to follow the curvature of the building, and they have to give that building that unique look. Middle there with the circles themselves are impact rate assistant. They didn't exist because they had to be embedded into the concrete, so those got tested for the project. The very large glass in the elevator as well. The elevator ended up being part of the building envelope, so that had to be designed. And the really large format panels there were supported by structural steel. That's how large those glass panels are, including the curved glass at the bottom was actually curved in the field to follow the structural steel. Quick note on what a label should look like. A lot of the architects in here, please make sure you look for these when you're signing off on a project at the end. This is a code mandated requirement. You'll see bottom left there, I believe we see TAS 202, the TAS application standards exactly. And we'll see the allowable wind pressures. And then the top right, we'll see reference to AMA 101. So that's the proof that, that the system has been tested and complies with the code requirements.
That's really hard to use, sorry.
Yeah.
So we'll see a few of the definitions that Manny was just talking about. Really, the high velocity hurricane zone is only considered Miami-Dade and Broward. It really has nothing to do with your wind speeds or anything like that. There used to be something called the South Florida Building Code, and really it's what's been adopted as now called the high velocity hurricane zone. You also have hurricane prone regions, which is from the US Atlantic Ocean to the Gulf Coast of Mexico, where your wind speed is greater than 115 miles per hour. And then you also have something called the windborne debris regions, which are areas within your hurricane-prone regions when they're 1 mile off the coast with 130 miles per hour wind speeds, or you are greater than 140 miles per hour wind speed. So here we have a map, and you'll see, I had to take a small geography lesson for this, but you'll see that about up till Massachusetts, you'll find that I don't know how to use this. So about up to Massachusetts, you'll find that it's a hurricane-prone region, down till about the Gulf of Mexico, where it's like Louisiana and Texas. And then 1 mile off of those coasts would be considered your windborne debris regions. You'll see down over there on the left, Alaska. They do have very high wind speeds, but they're not considered, at least not to our knowledge, they're not in the code as labeled as a hurricane-prone region. We haven't designed there yet. If anybody wants to design, we're in, but we don't know why it's like that. This is really a zoom in of Florida, and you'll notice that most of Florida, it really is a hurricane-prone region, and about half of it is your windborne debris regions, and then you'll see real small down in here, that's really your high-velocity hurricane zones, just these two. This is from the code itself. This is a section that's part of the non-high velocity hurricane zones. And really what it's telling you is your protection of openings need to be impact rated. And now they give you the option to test per TAS 201, 202, 203, or your ASTM standard for impact testing.
This is another one of those projects or products that didn't exist before. This whole tower essentially was a new design system. I think maybe the sliding glass doors were off the shelf. Concentrating on the glass lobby, these are, again, about 18-foot tall glass mullions. In this case, the outer glass is captured, not point supported. This is not a design by the facade contractor. This wasn't true design assist. The design architect came in and said, this is what I want. Guys, go make it work. And that was followed through to the point of the double doors at the bottom where they said, okay, fine, we'll accept a common commercial door. We don't want H-frames around it. And that was included in the testing protocol with Miami-Dade County.
This is really an alternative for just your impact resistance. This doesn't preclude you, though, from having to have your window engineered and tested for wind loads, air, and water. So just because you have shutters doesn't mean you don't have to do those things. It only takes care of impact. And this section is for your high velocity hurricane zone. Before we saw non-HVHZ zones, and this one says that when you're in high velocity hurricane zone, so Miami-Dade and Broward, all parts of the system of the envelope do need to comply with your impact resistance. That includes your doors, your walls, your roofs, your skylights, anything that really creates the envelope. You're going to be required to test for your large and small missile impact.
So you see that ASC 7, IBC 2021, and the FBC in multiple sections talk about opening protection. So it's not it's not a Miami thing, it's not a Florida thing. It's coming from the design of buildings themselves. So I know that there's a few structural engineers in the room. As you're designing buildings, and I remember the RWDI presentation, there's components of external pressure acting on the building and internal pressure coefficients acting on the building. And you'll see I guess if you can kind of read at the middle, the second column to the left, actually, there's a bunch of math there that basically defines the type of enclosure that you have. And it varies between enclosed, partially open, et cetera. But if you notice the red and yellow and green arrows, green and yellow are coming up at 0.18 internal pressure coefficient. The red arrow is triple. So who here has heard, you should probably open a window during a storm to, let the wind down, right? Don't do it. Because unless you're going to do all this math right before the storm hits, you might mess up the building design and turn it into a triple, basically increase the design pressure coefficient, the internal pressure coefficient by 3, and potentially cause a collapse of a building. Obviously, it's a little extreme, but it is a big factor in the design. A little bit of a silver lining in the code. So, as Cristina mentioned before, the only place we've seen that the codes say every part of the building envelope has to be tested for impact is the Miami-Dade and Broward codes. It's not mentioned anywhere else in the codes. But they don't tell you, wait a minute, there are things that are deemed to comply. We're not going to make them test. We're not going to make you test it. Concrete walls, masonry walls, wood frame structures, and steel frame structures with limitations. So wood frame structures, both roofs and walls, they want to see essentially 5/8 plywood. In the case of walls with wire lath and stucco, in the case of roofs with an approved roof system. And then you have rib gauge deck type material for the steel. A quick note on the plywood. We see a lot of non-plywood sheathing outside Miami-Dade and Broward, and it's hard to say, hey, you can't do that, because the code outside Miami-Dade and Broward doesn't explicitly say they can't do it. So essentially, you'll see assemblies of some other sheathing with potentially lath and stucco or another specialty finish, and it's accepted as an impact rated system, but it's not. Another quick project. This is just showing that it doesn't have to be a glaze system that needs to be tested. So in this case, the GFRC panels do make part of the building envelope in between the window wall system. That also had to be tested and approved. And again, it was decided very, very, very early that it was going to be tested and approved. This is really, if you want to get your cameras out, this is really the summary of this 20-minute presentation. It's showing that AMA 101, depending on the system, we'll have about 5 tests, right? If it's an operable system, you'll have operating forces, you have your air and water intrusion resistance, then you'll have your uniform load test where you'll check your deflection, that's your design pressure, and then you have your uniform structural load, which is essentially your proof load. And I think you may have seen 1.5 times the design load. What does the impact rated sections ask for? They only add 2 more tests. So if you go to a lab, they're gonna say, sure, bring me the same sample, I'll test it, I'll just shoot it and cycle it. And that's really the magic of the impact rated system is you shoot it, you break it, and then you cycle it 9,000 times. And I know some of the presenters kind of talked about this. It's not magic. It's just break it, cycle it. If it doesn't break, it passed. So again, if you take anything from today is don't be afraid of this. Don't listen to the contractor that says, I'm the only one that has this approved. Anybody can do it. And I think some of the projects that we've seen today is proof of that. Real quickly, because I think we're almost out of time, this is just showing that you have multiple options for product approvals. I think somebody mentioned a one-time product approval. A lot of the projects that you see that we worked on, the designer or our client, the glazing contractor, chose to do it as a one-time product approval because it stayed off of the public realm. Once it gets into an NOA or a Florida approval system, everybody can essentially see your product. And then we've seen that in some of the presentations, they've been taken into new product lines. So there's an incentive for the smart glazing contractors to say, yeah, I'll spend the money testing on this project. I'm going to sell it later, basically, because it's their product. Real quickly, a test protocol as small as we can make it. Air infiltration testing at the top. That's an AMA. There's differences here. For example, you'll see that the load duration of the test are like 30 seconds. The AMA test might be 10 seconds. So Miami-Dade does make it more stringent, but they don't reinvent the wheel on the test process, essentially. And you'll see the impact and cyclic and everything else. For the engineers, and even for the architects, there's no difference if I'm designing a project up in, I don't know, Alabama or if I'm designing in Florida. I have to check my wind loads, I have to check my stresses, I have to check my deflection, I have to check connection. It cannot leak air or water, and it has to be thermally efficient. The only difference is that we increase the wind pressures in hurricane-prone regions, and we might add impact resistance requirements. But the rest of it is the same math, essentially.
And this is a simple calculator that you can use. It's just an Excel file with AutoCAD. You create regions, you get your section properties, plug it into your calculator, given that you have your wind loads already, and it'll give you an allowable stress that you can use to design your actual mullions. Most of your projects are going to fall within this. You can probably use something as simple as this. They're going to be designed as simple beams with simple beam formulas. This is where most of them will fall, but you also have these more powerful and complex design tools that you can use. Typically, these won't be used on the early stages of your project, but your facade consultant should and can be providing these throughout the project. And then this one is really a finite element analysis of glass. You can use something that doesn't fall within a regular rectangle, and you can use your ASTM E1300. This one uses finite analysis to either do a different shape or do some point-supported glass that'll give you more stresses on your glass.
So this is the last one on the presentation, I mean the samples. This is the Twisting Tower, Grove at Grand Bay. You would assume that it was a complex building for the facade contractor. It wasn't, it was just the standard 4-foot wide Florida window wall systems. But we picked the lobby because I think this is the first time we saw a 20+ foot single span window wall system in essentially a high-rise construction. So the wind loads were about 125 PSF. Again, large missile impact rated, no steel used or no separate steel used even at the 4-panel door opening that you see there at the bottom. So again, this one was done really, really quickly. The architect came in and said, here's my layout. Go crazy, go design, go test, go do everything. They did not come back and say, what can you guys do? Basically, they told us what they wanted on the project.
And we did it with 1 minute to spare.
There we go.
Thank you.
Perfect.
Thank you guys for such an informative presentation from seasoned experts in this industry. Definitely a great presentation. Thank you. Next up is going to be Joseph Chase from SOM. He's known for material innovation, and he's going to take us on an inside material evolution on one flagler from the cast-in-place precast concrete.
Hello. I'm Joseph Chase. I'm a principal at SOM. I'm going to walk through today our recently completed one flagler project. Sorry, let me grab the clicker. One flagler is the first in a new wave of buildings in West Palm Beach that are changing the city into a major urban center. The 285,000 square foot LEED Gold building just opened this year, fully leased, with tenants from around the country. From the beginning, it had a strong concept related to the idea of a white trellis extending from a public park. And I would say also that it drew its inspiration from a rich tradition of Florida's tropical modernism. So the design was led by David Childs and Chris Cooper, who worked with Related Ross on developing a vision that reinforced its place in West Palm Beach. David Childs, who just died last month, this was his last project, and I think it is a good capstone to an illustrious career. So really inspired by the site, the design vision developed 3 guiding principles. We tried to establish a landmark or a beacon across the water. We tried to reinforce an axial relationship to the water. And we tried to reinforce the historic architecture of the site. So, like a lighthouse, the building sits prominently along the Intercoastal Walkway, along South Flagler Drive. The illuminated crown marks the entry to West Palm Beach as you cross Royal Park Bridge. With a side core, the building orients all the spaces to the ocean, with Palm Beach framing the horizon line. Conceived as a single site with the historic First Church of Christ scientist, the precast frame complements the existing classical design with a contemporary rationalist equivalent. Once the project was established, the technical team, which I led, tried to explore different ways to implement this approach. We knew the building would be concrete, but we wanted to push the details in new contemporary directions. We tried to keep the design crisp, precise, and very light. We wanted to avoid all the roughness and heaviness of mid-century brutalism. We also noted that Florida in recent years has been at the forefront of developing a new language of concrete. This language is at once aware of modernism, but geared towards expressions of whimsy and play. And we feel that One Flagler very much fits within this trend. So the team that worked on this project was initially working on a project in New York City. This is 1245 Broadway, which is a cast-in-place concrete building. And our initial take for the site and for the project was to try to expand on the research that we did on this project and try to do a cast-in-place project for One Flagler. And in general, SOM has a long-standing tradition of integrating structure and architecture. Historic projects like the Hirshhorn, shown on the image here, unify structure and cladding into a single system. In our minds, we think that this has great benefits for carbon reduction and sustainability, since everything is combined into a single layer, limiting the need for extra cladding layers for additional carbon. And I think with One Flagler, we really tried to make the building an expression of structure. So in 1245 Broadway, we knew that cast in place comes with a commitment to mocking up concrete. So you can see we started with tombstones on the far left. We moved to 4x4s at a bigger size. And then we moved to full building components. And each step along the way, we would test things like the sealers, the color, bug holes, workmanship, and such. So for One Flagler, when we discussed this with Related Ross, they were open to cast-in-place concrete, but they really stressed the critical importance of having the highest level of concrete finish. The types of tenants they were seeking and the types of rents that they were pursuing really demanded a building that needed to be crisp and needed to be of high quality. So we proceeded to document two schemes. One scheme was the cast-in-place option, but we also documented a precast option. We tried to outline the pros and cons of both of the schemes, and we tried to, in a very fair way, show how each of them would create both benefits for construction, but benefits for the real estate. So one of the major benefits of the cast-in-place concrete option was to the interior design. Having a facade that is structural allows for unencumbered views and a flush relationship between the glass and the concrete. Obviously, once you add the columns to the inside and make the facade cladding, the planning for the interior becomes not as good. So, as I mentioned, we documented two entirely different structural systems at schematic design. We proceeded to then discuss these with the contractor, who was Coastal Construction, and tried to sort of fairly judge the merits of both. TT, who was the engineer for the project, sort of engineered the profile on the right, which is structural, and then obviously as we went into schematic design, the precast is on the left. So at the same time, Coastal started to solicit samples from Gate Precast in Kissimmee to sort of explore the possibilities of precast. Gate provided a set of samples with various textures and colors, and we then had them build a mock-up. And this is, again, pre-award, pre-them actually having any agreement in place to try to make the decision on whether we wanted to do a cast-in-place building or we wanted to do a precast building. And I think through this process, we learned that we really loved this finish. I think the client really loved this finish. I think Steve Ross wanted a building that really looked like stone. And I think the quality of the craftsmanship of the precast really tipped the register from a cast-in-place project to a precast project. So once we shifted to precast, we had a new challenge. The challenge was, how do we make a precast donut not look like a mid-century brutalist building, right? And we quickly pointed out to the client that really a lot of that language comes from the location of the joints, right? So we said we didn't want the joints in the middle of the panel. So we looked at options. So the option, and this is very similar to what we ended up with, is to create a panel that overlapped each other to effectively set the joints to the side, and then we use this sort of trim element to then hide the joint. I think this subtle move kind of radically changes this facade and takes it from something that's sort of mid-century and puts it into a contemporary language. So at the time, Gate was on board, but we had not yet selected a glazing contractor. So we looked at both systems that allowed the glass to be set independently of the precast, and we looked at systems where the glass was set within the donut. In the first option, the precast T, that allowed each individual T to be set independent of the window, and then the window could be set at a different sequence. You can see each offered unique but subtle variations related to that tectonic, with the precast T on the right and the precast donut on the left. And then this also offered us opportunities for looking at how it could be unitized or panelized for trucking, for both speed of installation and for its impacts on the aesthetics. So you can see we looked at single bays, we looked at double bays, and we looked at vertical double bays. So at SOM, we like to get into the details. We like to even play contractor from time to time. So we like to visualize a lot of how these things would get set, how would they get installed, how they would get sealed, and we tried to help the owner make decisions or judgments on how to move forward. So here's the donut scheme, the process of setting, how it would be sealed, and then here's the T scheme, sort of explaining the differences. So obviously with each of these systems comes with different levels of complexity with the sealants and how that sealant would be applied. The T was much simpler, the donut a little bit more complex. And then obviously how that affects the relationship to the interior and how a site glaze system would be different than a donut-based system and how that even affected the calculations of the FAR. One of the major advantages of the T, although it was slower, was that you had a single line of weather protection all along the face where the precast was acting more like a rain screen, whereas the donut, the precast itself was part of the weather protection system where the insulation was on the backside, creating a much more complex relationship to the dew point. And you can see that in section also, the simplicity of the T from a weather protection perspective versus the donut. So ultimately, the donut won out. I think again, this project was very much tied to lease turnovers and speed of construction. The donut really was much faster, and at this time, I think Related was ready to award who the glazing contractor was. I put this in here just to show that these sizes were optimized with trucking requirements and all the necessities for bringing the panels to site. So we did bring West Tampa Glass on board, who is located here in Tampa, Gate up in Kissimmee, and the site down in West Palm. Really the strategy was for West Tampa to get their glass from Technoglass in Columbia, assemble the units in West Tampa Glass, ship those units to Kissimmee, which then put them into the donuts and then ship them to the site. Again, as a basic strategy to meet time constraints, we had all standard systems with standard Florida product approvals associated with them, no custom testing. And I think we, even with standard systems, came out with a very bespoke project. So just to show some images of how we focused on the details for the project, this is the mock-up, the visual mock-up that we created for the project. You can see how we created this sort of flyby detail where the precast seems to float above the panel above it. You can see how we looked for bug holes and tried to make sure that the burnished finish that we selected was uniformly applied. And then we tried to make sure that all of the craftsmanship and alignments were as perfect as we could get them. Again, we did do a performance test, really for testing the interface between the systems. There was some cracking in the precast, which we addressed with additional rebar in the precast as we moved along. You can see the extra rebar that Gate added to the precast, primarily to deal with shipping concerns, and hoisting was the assumption. So again, we did, as part of our scope, robust site visits where we looked at every single panel before it went to the site. And then obviously some shop drawings from the Gate team. And then ultimately we ended up with a double donut to speed installation. Some additional pictures of the project on site. And then some of the engineered clip details for supporting the precast. This was all a design assist process. So we worked with Gate to sort of come up with an approach that we liked aesthetically from the interior, but also met all their requirements. Again, the anchors from the top. And then again, some of the views during construction showing the double donuts. We had a unique corner condition where we had an open corner and we had a precast piece that was this sort of L shape that sort of fit into the corner. And then, as I mentioned, we really took the thesis that we needed to hide these joints to really make it almost appear like a cast-in-place building. And you can see we had this additional trim element added to the standard West Tampa glass system to then hide those sealant joints. Those clips were all installed in the field off of baskets in order to do a second round to conceal the joint. And then you can see how that detail, again, relates to the head detail, again, with the intent of hiding the joint. It also had the added benefit of really trying to accentuate the depth of the precast system to make it as deep as possible and to give the building some texture and to make it seem like a frame. So the final design, I think everyone's really happy with. Some of the pictures to show the final design are shown here. We've got a public park at the base of the building to the right. This image from above, an aerial view, shows how all the terraces are landscaped and programmed and shows just the high level of precision that came out with this precast project. And just to show, the project at night, this ambition to create a beacon, to create a landmark, a lighthouse even at the water, was really manifest with the lighting scheme at the top, where we have a light integrated into this continuous crown at the roof level. And then at the base, this is the main entry where we do have the drop-off, the porte-cochere for the office tenants coming to the building. We've switched to, again, stone on the walls. The interior glass is, again, a standard system from West Tampa Glass.
Thank you, Joseph, for such a detailed and creative presentation. Next, we have, from DeSimone, we have two, Danilo, Nanni, and Benjamin Reich. They're going to be experts in talking about uniting logic with architectural vision, and they're going to share real-world case studies on discussing envelopes on some iconic projects in Miami.
So,
This afternoon, we are here to present what has been important for us to discover a methodology of work, some case study, and what we learned and what we can now confidently share with you. I'm Danilo Nanni, principal with DeSimone. I represent the structure in this marriage with structure and facade. And
I'm Ben Reich, associate principal with DeSimone of the Facades and Restoration Group.
Now, let's have, just to start, a nice picture of Miami, the central building with design, to kind of give us like an idea of the complexity of the building and the structure. But now, if you want to go over some of the what DeSimone is becoming.
So the firm was founded in 1969 in New York City. We celebrated our 50th anniversary in 2019. We currently have offices really all over the world, and we've completed over 13,000 projects in the firm's history. So these are some of the services that DeSimone offers. So we've added quite a few offerings and diversified quite a bit since we started 50 years ago.
Now, on the structural design, I'd like to say a couple of words because it will be important in which way we are working with a facade. Now, if we have here a very sleek building and a damper, this is a way to benefit the structure, to benefit the facade. But what we're really doing, we're expanding our practice. So the wind engineering that we have at the bottom of the list is actually something that we're integrating up front in our firm. So to have basically yearly understanding what the wind is going to do, how we can alter even the architecture beside the structure to have the wind kind of working for us, if you wish. And obviously, we have other interesting renovation preservation that is getting stronger and stronger in Miami, beside everything else that is typical for DeSimone. I think the next one is yours.
So our new construction building enclosure group includes glazing and cladding systems, roofing and waterproofing, energy analysis, as well as facade access and maintenance. We also have a group that does facade restoration of existing buildings.
Yes, and now it comes the fun. If you go to the next one, let me just give a couple of words about the structure here. This is, we just had a ribbon cutting ceremony, and this is the kind of project that is teaching us a lesson. Because everything has been built in Italy, that is basically structural, all the structural steel, assembled in Italy, in Viareggio, which is in the northern of Italy, and shipped here, which means that there is very little that we can do after the fact to correct, adjust, regulate, and the fine-tuning. So everything has to be fairly coordinated. And when you see those lines basically, they are kind of telling the story of what basically the facade is doing. Now, the other thing is that you have to look at the scale. We're talking 2,000 feet. 2,000 feet, it is berth number 8 and berth number 9, one after the other, so they accommodate 2 vessels, including the New World of America from MSC, one immense vessel. What I can say about the structure, and maybe this tells a little bit more, we had all kinds of complication in terms of analysis because we have the thrust given from the inclined column. We have obviously 2,000 feet, which basically means to have expansion joint, oversized expansion joint, means to have ocean front with risk category 3, means to have basically all kinds of small tolerances to have the facade work, because what you don't see here, and Ben will explain, that we had a 40-feet span and in between wing columns. And the wing columns were basically supporting large cantilever. So what it boils down to is that through all the facade, you had a very difficult supporting condition to the facade, very different deflection, and still we had to maintain this regularity. And Ben did alpha miracle. Explain them more.
So we worked closely with the architect as the facade and envelope consultant on this project, and from the beginning we had to coordinate very closely with the structural system to achieve these horizontal brow features that you can see converge as you move towards the east, and really starting to develop these systems and design. You can see these wind columns and these horizontal tubes that are supporting these profiles. We really had to go work hand in hand with one another. So this was a unitized curtain wall system. We actually had 3 different systems in this project that were tested together for structural, air, water, and impact testing for the high velocity hurricane zone. And really from the beginning, it was important that we marry these 2 disciplines and work closely with each other. Great. This is another example of really working hand in hand with our structural team. This project is in New York and in Brooklyn. It's called Olympia Dumbo. It's a 6-story podium with 20 stories of residential condominium above. And from the beginning, one of the challenges was accommodating the varying geometry at each floor to get these sort of torquing balconies or twisting balconies, and also addressing all of the waterproofing and considerations, and working through details like this at the terraces and the balconies. It really shows how closely the glazing systems, the structure, the waterproofing, really all had to be closely coordinated with the structural design. This is a unitized window wall system from ELIC. Some images during construction showing the sloping columns and the twisting floor plates. And then this is an image of the finished building. These are actually renderings. It's hard to tell the difference, but great.
Yes, and this is part of what we learned in terms of the geometry of the building, the geometry of the tower, how to integrate the roofing when you have basically costly units. And then this is a building that I love to show on every possible opportunity that I have, if it's or not fits, or if it's partially, because it's a building that should have had such challenge from any point of view, particularly from the wind, because of the wind condition, the shape, the wind. It looked like a wing of a plane. So it's a building that it should have been penalized greatly from basically the wind forces. Now, what is interesting, this is one of our first slides, we are approaching more and more understanding the wind engineering. So what we're focusing on this building, there is something that I love to show because it's so intuitive. It's extremely intuitive. Why basically a ping pong ball is done in a certain way and why a golf ball is done in a different way. So when we have a building that wants to look sleek and basically not have irregularity, sometimes like an office building most of the time, sometimes we have to deal with a drag from the wind, the laminar flow. But if we manage to introduce strategically some rugosity to the right point, then we see that there is a separation and that there is a turbulence, and really we don't have the kind of negative effect that the shape of the building, the fact that it's somehow looking sleek, will basically supposed to have. In this case here, this little, I wouldn't call it balconies, even though they are within the perimeter, that's enough. On the other hand, there's also enough. And that is what grants you a reduction of 20% or more from the code, aside of the shape of the building, aside of this beautiful architectural element, which is where you have the pool deck, that even though it's so prominent, it does a lot. It's part of the reduction of the wind load, therefore less torsion, therefore better behavior of the shear wall, therefore better behavior of the facade, which receive a lot less load, because remember that when the stability of the building is granted, even the cladding is basically benefit from that. Now, I'll take that element and as lesson learned, and I move to the next building, which is basically the way that we link these two together. This is, in my opinion, even more interesting because first, for a philosophical point of view, in a place where you have a maximization of profit, to see a building that is a triangle in this way, instead of being in the opposite way, which means it's like a pyramid. It's just beauty, because when we have to work with extrusions or with building, they always maximize consideration of square footage to sell, to see basically this shape is in itself a beauty. Now, what we're doing here, we have basically that element that we want to understand and see how we can put the maximum to work. So we have our internal specialist with wind working yearly with the wind tunnel, working with the facade, the structure, so to find the sweet point that yearly in the game, but because we are in schematic here, so it's super yearly, already puts us in the right path. So this is the lesson learned, what we learn from everything, starting with MSc, and also before that this has to happen yearly to be really effective. And when it happens yearly, it comes without effort. So here a couple of key challenges, balconies. Balconies just because of the shape. We saw in New York, you have a component of roofing, and Ben will take more. The amenity deck everywhere, the waterproofing. So that's really typical, but the way that we attack it. This is too beautiful for an engineer. I gave it to Ben because this is...
So some of the similar challenges that we faced at Olympia in Brooklyn and with MSC in a high-velocity hurricane zone. Again, the balconies are strategically deployed. It's a desirable feature, but it also benefits the overall structure from a wind design standpoint. But also looking at the planting and the pool on the deck, all of the structural coordination and waterproofing all needs to work together hand in hand. The double height glazing systems at these amenity levels, again, will need to be considered in this context, and it's really something that we feel confident we're going to be able to handle.
Yeah, we can say a couple of words here when we strip and we just leave some elements. So what we want to understand here is basically what are the supporting conditions of the facade, because the key is always to have something that is applicable, a good standard, and make sure that it works effectively everywhere. And basically, you don't have kind of the surprise of deflection, deformation, or anything that wasn't seen at the very beginning and creating the long-term problem. Now, this one already gives some intuitive understanding that the supporting condition varies at every floor. Now, we have the last slide that is a little bit brutalist, but it's effective, because it being so brutal, it basically gives intuitively an idea how every floor has different supporting condition. So everything that is on this side of the tower has to employ something that works for the entire tower, but something that works with the right tolerances that even though you see you have different cantilever, you have different backspan, you have all the forces that has to be picked up by basically when you have a truss that comes by the inclined elements, all that needs to be resolved at the end. Now, every tower has differential settlement. This one we try not to have much as such because we are planning in advance and we have a belt truss, but all that goes into the calculation because then you have again the triangle that keeps going, and basically all that has to work together with the rest, but there is individual design to stay within the tolerance, to stay within basically the performance that is intended. Really what we wanted to present here, the lesson learned, that is the schematic phase, the moment that you really have to start thinking when the building is complex, to the facade, to the wind, to the structure, to integrate all that. Because once you already take a direction, sometimes it starts to be difficult to adjust and basically work too much over that. So really, this is the message we wanted to show. And I think we are done with that. We stayed in the time, but we wanted to basically share a methodology of work that we're implementing at DeSimone with this project.
Thank you both for bringing structure and envelope together in harmony. So we have our last panel of the day. Is going to be a high energy panel consisting of Lisa Ramming, Director of Eckerle O'Callaghan, Norman Hu, Director Design of Swire Properties, and Daniel Dayon, Director of KPF. They're going to talk about facade strategy, resilience, and regional adoption. And we're going to take a few minutes to get everybody set up. Thank you.
All right. Hello, everybody. So, this panel we have here now is going to be very exciting.
How should we?
You guys take a seat.
Should be in the center, probably.
Because what we're going to talk about is the building we're in right now. So my name's Lisa Ramick. I'm with Eckerle O'Callaghan. We're facade engineers. And I have the pleasure today to talk to Norman and Dan. Norman is from Swire Properties and Dan from KPF. And we're going to talk about what will be happening with this building that Swire have owned for a long time in the future. We might need some slides. We good? So the way that we're going to do this is Norman is going to show us a little bit about the history of the building, and then Dan will go into the design of the new building, and we'll do a little bit of a back and forth, and then we'll have a conversation about what have they learned in that process, and how does that relate to the way that Swire work internationally. The way that we have come together today is a few years ago, I worked on a project in Hong Kong with KPF, and at the same time, we were just starting a project with Swire in Hong Kong, which has very similar design requirements to Miami, but has a fundamentally different approach. And recently we were talking about that, so we thought we should use the opportunity here in Miami to talk about how do these two cities come together and what kind of similar requirements do we have, but how are they being addressed in a different way, particularly when it comes to facades. So once we've got the presentation up.
Okay, great. Thanks, everybody. It's a privilege and indeed an honor for me to be here today. To speak to everyone, and thank you, Zach, for inviting us and EOC as well. I suppose we can skip these slides. So, just a little bit background about the project and about the company. I'm Norman from Swire Properties. I've been with the company a little more than 10 years. Not everybody knows here, but Swire Properties, even though you guys think we're a Florida-based company, we're actually a Hong Kong-based developer. And we've actually been around for more than 200 years as a highly diversified conglomerate. And the Swire Properties has been around a little more than 50 years. We've established since 1972. We develop mostly big master plans of mixed-use development of retail, commercial, residential, hotel. It's always mixed use. And what sets us apart from most other developers in this market is that we are extremely long-term focused. And that really has enabled us to look at building quite differently because we are willing to invest heavily into the building for quality because we intend to hold them for a very, very long period, except this particular project. So kind of deviated from our launch, but I'll get into it a little bit more why. And we also think of ourselves less so about a developer. We think of ourselves as placemakers. That's all about giving place, creatively transforming places. And here's a sample of different projects we've done over the years, and you can tell that we are not afraid to take risks. We work with very talented, global sets of talent. We willing to explore in different styles and facade system. We are not afraid of complexities, and we are certainly willing to invest into the quality, like I mentioned. Now, fast forward a bit. we've been in Miami for actually almost 50 years. We've established since 1976. We are most well known for actually the Brickell City Center, and as well as the Brickell Key, which I'm about to show you. We've actually have ownership of the key since the 1970s. Just fast forward a bit. So today actually marks a very, very special day because in 2 hours after this panel, we're about to head off to the closing party of the Mandarin Oriental. It's actually closing in 2 weeks, and tonight is the party to celebrate that is serving us for the good last 25 years. As you can see here on the key, Swire has acquired the island since 1979, which is also the same year we've established here. And we've actually, been developing this for the last 40 odd years, and we turned it from a site where people just dump the dredges from the Miami River into a piece of really valuable real estate. Starting with a few of the Brickell Key 1 to 1, 2, and 3 Tequesta, the Courvoisier Center, the connection of the bridges. I mean, there's a lot of history behind this island. Actually, the island is more than 100 years old. But I'm going to save that story for another time. But what I intend to show you is this 40, 50-year master plan that Swire has for this site that culminated in the development of the Mandarin Oriental Miami that you see here today, back in 1999. And, because of, when we developed this site, we've never envisioned the growth of Miami, to experience this kind of explosive growth after COVID. And the hotel has only about 300 keys or so, and it's a little under amenitized. But we also have looked at all different options of upgrading it, doing a wholesale gutting, and renovating, doing facade replacement. But none of those would make sense until we take into the unused FAR of the hotel and turn it into something in order for it to pencil out. So this is what brought us here today. We have a vision, and this is going to be the third time that Swire Properties and Mandarin Oriental, collaborate and join forces. Matter of fact, fun fact, both companies are based in Hong Kong, and we are both 200 years old. Swire is owned by the Swire family, the Swire Group. Mandarin Oriental is owned by the Jardine family, the Jardine Matheson Group. Now it's the Kilpatrick family. We are both have handed over 6 times. We're on the 7th generation, and we are actually consummating the marriage for the 3rd time again here in Miami. Normally, we are rivals in Hong Kong between the two groups. So. But here, we're a happy family. And we actually, search around the world for the best talent, and, we, found KPF. We assembled the best team, as well as the key supporting consultant team to work on this tower, to turn this sketch into what you see here, the new Mandarin Oriental with the residences and the new hotel. The new tower is going to be featuring 2 towers, the south and the north tower. The T1 is the south tower, which features 228 private residences. 66 floors, we have 2 penthouse duplex on the top. On Tower 2, which is the north tower, we have 121 keys of the hotel room, the new Mandarin Oriental, which is a much smaller hotel, more boutique, but it's going to be highly amenitized. It comes with 160,000 square foot of amenities shared between Tower 1 and Tower 2. And we're under-reporting that as well. In reality, there's a lot more. On top of the hotel, we have 28 keys of hotel residence. And on top of that, we have 66 more private residents. And the target buyers are very different. The Tower 2 buyers tend to be people that actually want to be living in the hotel lifestyle, being in the hotel tower, versus the Tower 1, where they actually want to be secluded, to be, enjoying the privacy where you just don't throw away from Brickell, but you're still enjoying the resort lifestyle that we're providing. And this tower essentially would complete the vision we had for the Brickell Key, for the last 50 years. And now we're going to hand over to Dan to talk about this amazing design that they have dreamed up for us.
Oh, thank you. That's the one. Okay. So my name is Daniel Dadorian. I've been at KPF for about 18 years, been working on this project for 2.5 years. So it's a really good place now. And before I talk about this project, I wanted to talk about something that you guys probably know more about than I do, which is the Florida room. And, thinking about this project, it does make me think about pre-air conditioning houses in a way, in the sense that you know, all the Paul Rudolph sort of experiments in Florida all over, all those houses seem to be, you know, they talk about not just proximity to nature, but also creating, I mean, this is a beautiful house where you create these conditions where you have to traverse from one place to the house, of one area of the house to the other to feel comfortable, not necessarily having the luxury of cranking up the air conditioning in order to feel comfortable wherever you are, but rather you kind of have to move through different conditions that the house offered. And then the Florida room obviously was part of that, one of those conditions in the house where you had shading, you had the horizontal surface that gave you shading, but you got comfort and you were able to open up the space, you were able to close the space as you needed. So in a way, the house acclimated and you acclimated in the house by moving through it. So coming to here, you know, where, you know, obviously air conditioning is prevalent and is needed, we thought about, well, how do we bring back island living to the city? And that one way to do it is, of course, there's a lot of lushness in the project, both at the podium deck and at different levels of the project. The podium has different sort of terraces where you have a lot of lushness, but also a lot of the architecture and the amenities are sort of embedded in the natural landscape. So many of the functions that the users would actually end up using are embedded in an area where, like, we have a whole kind of like almost like a forest-like environment. There's areas where they're more kind of intimate enclosures where you're relying on simply natural ventilation to cool the space, and then you have also artificial cooling as well, like this space here. And you know, we're working with DeSimone on these sort of oversized glass systems that give you the most sort of transparency to see the views, to introduce these screens, but also to be able to open up these enclosures and get the breezes through. So really beautiful sort of pavilions that are set in a garden setting. Now, this is also carried through into the units and also the sort of amenity spaces that are serving the residents. So you've got these sliding systems that substantially open up the spaces, while you've got these overhangs that give you the shading that you need. And within the units is where we're sort of exploring the Florida room and the outdoor living room idea more thoroughly. And one of the features in the building, which is quite unique, is the courtyard, which some of the units offer pretty commodious, generous courtyards that protect you partially from the wind, but also are quite pleasant to use. They're actually usable balconies. Oftentimes, I think we see balconies that look like balconies, but you can sort of stand in the balcony, but can't fully use the balcony. So there's a lot of like usable outdoor spaces that allow you to have breezes, but also some level of protection and shade. So, and I believe those units have been popular. Also, you know, we have a lot of simple kind of very deep outdoor living conditions as well, which in some units we also offer through circulation, a little bit like the Rudolph houses where you allow for air to pass through from one end to the other. And even though we have these very deep overhangs that give you passive shading, the daylighting aspect of the apartments is still quite successful. There's no issue. We were worried about it. We thought, well, these are really deep balconies. What's happening to units? But all the analyses we did revealed that, like, on the daylight front, we're still good in Miami, which wouldn't necessarily happen in New York. The other thing that's interesting about how we explored the balconies was the color of the tower, or the coloration of the tower in general. We have a sort of a bullnose design that is an aluminum bullnose that allowed us to explore color and how the tower could connect to the sky, especially since it's an object that's sort of standing at the tip of an island and kind of has a lot of sky around it. So that's where the gradient idea came to mind for us. And we were thinking, well, how can we use aluminum, and how can we use the sort of the ability to accurately paint the edge to somehow connect the tower back to the sky. So this is where we thought about this idea of an earth tone that kind of slowly dissolves into a very sort of a white tone at the top of the tower. So, which involves using, I think, a range of about 30 or so colors to achieve that effect, which you'd experience both looking at it from a distance, but also when you look up at the tower and it kind of like disappears into a sort of a white tone. And of course, the sort of like the folding of the bullnose contributes to that, because you could actually see the color fading up. And in that sense, it's also distinguished from a background of towers that is a little bit more sort of monochrome in some ways. But we thought, why not use the bullnose and use the idea of like painting to achieve a sort of a reading of the tower against the sky. Geometry is also something we should talk about. It has a very distinctive geometry, but also in working with CPP, we were able to achieve pretty significant reductions to the wind loads on the tower, thanks to the geometry of the tower. So we were hitting something like 18–19% reduction in wind loads, which of course, again, we're working with DeSimone structure, that yielded savings in terms of the concrete and in terms of the structuring of the whole tower. So the curvature of the whole, the shaping and the geometries really helped a lot with the windows. And of course, being at the tip of an island, it's probably going to get a few breezes, and like and also that was top of mind for us for a tower that's at the tip of an island in Miami. So the geometry was really working with us on that front as well. And that also is the progenitor of the sort of like the pretty open screen at the top, even though we wanted some solidity at the top, which we often do in other towers. But in this case, we really had to work with CPP to achieve the right porosity so that we don't get unnecessary pressures on the tower if we had something very solid at the top. And that's where the porosity at the top helped us. And that's where the sort of like the double curved mesh screen came to play. This is at the penthouse of T1. And of course at T1, we also, at the penthouse, we looked at using oversized glass panels, which is obviously something we'd want to look at given the amazing views we have from the site. And I think Norman will speak more to where we actually are exploring large panel glasses, glass pieces.
Thank you. Just want to, because obviously I've spent the last 10 years of my career in Hong Kong. We worked with obviously EOC, which taught us to be fearless. Anything that you can dream of, you can design. I want to show you the tale of two cities. So coming from Hong Kong to Miami, they're both not so dissimilar characteristic of the city. It's all a city of concrete and glass, but the actual facade expression of the two cities are so different because, in my opinion, I believe, it's because we have a very different supply chain. And despite we have exactly the same wind load, we have typhoon in Hong Kong. You guys have hurricane here. It just spins the opposite direction. We're on almost exactly the same latitude. And our wind code in Hong Kong is way more stringent than Miami. We have a safety factor of roughly 4. So whatever the peak wind load, we have to design to times 4. That's how the glass buildup gets derived. And even so, we are not afraid of actually just keep pushing and trying new facade technology, where we are trying to do more with less. Case in point here, this is a few of those special moments in the tower where we want to start exploring jumbo glasses where they go up to 10 meters or 30 feet or so. What previously was even higher, where it was 45 feet or 15 meters or so. To us, that's nothing. We don't feel anything uncomfortable about it because we've done it before with these. Obviously with the help of EOC and the robust supply chain that we have. And you can tell that to be able to have a piece of glass where there are no structure, where there are zero distance between you and the view that you are seeing, are what the buyers are ultimately buying into, that luxury of seamlessness. So we looked around and we're just thinking, how can we we have this ambition, right? We have this dream of just trying to achieve it. And we have just my last project, we've actually done it. I want to show you the last project where we're working with EOC. This is the 2 Taikoo Place mixed-use development here, where it's a 3 million square foot complex with, demolishing 2 buildings, we're building 3 new towers. So 3 buildings and then building 2 new towers. And what we've done is taking, at the time of completion, we've actually built a 15-meter, a 45 feet tall glass wall. You can see the scale of that person to the image over here. He's a 6 foot tall guy. You can just tell the scale of that glass. And at the time, we hold the Guinness World Record, the tallest piece of curved glass in a hurricane zone, where we're actually designing the glass wall, allowing it to move up to a whole foot during the hurricane. And there are a ton of systems available to us that we could have gone for. These are things that you probably see around Miami, but we chose, you know what, let's just try the craziest idea we have. Why not do, with EOC's help, just create a rod that has no structure, where there's 0 distance between you and the environment that you are designing for. And obviously you can see some of the analysis, they've done behind the scene, and here's the detail. Hope I'm not giving away any major secret. And you can see the glass during the hurricane or typhoon, it will actually bulge like that, and we have actually done measuring on top of it. But with the right engineering way, only this top-bottom capture. This thing has been performed beautifully in Hong Kong. Here are some installation photographs that we can show you. And behind you is a mini documentary that we've actually done, showing the process of, because we have working with North Glass in China, out of Tianjin, and they are just an incredible partner. They're willing to invest and buy new machinery for us. They develop new coating, new laminations, new bending. See, there you go, new bending machine to actually create this 40 feet of glass. We have to shut, even new special logistics, right? We need to shut the tunnel at night after midnight to have a special route that we can deliver the glass to get it installed. And this is the kind of stuff that excites us as Swire Properties, right? We're not afraid of the challenges. And that same philosophy, we also want to take it to the tower, where you can see on the left, we could have gone with the convention system where it's a 4.5 feet glass module, with the mullion depth about 8 inches. But EOC is so crazy in their engineering skills that they actually can use the same mullion profile that's 8 inches deep to span something that's 9 foot wide, 3 meter wide panels. So, they've completely changed the way our perception of, how to do more with less if you just be a little more thoughtful and be able to just challenge the convention. And that's really what we are trying to bring to this project here, with the right partner and the right supplier and the right fabricator and then installer. We really think that there's so much potential here and opportunities in Miami that collectively, this industry can, take a leap, forward, like how we had it in Hong Kong. So this is really
awesome. Thank you very much, guys, for taking us through that story. I want to start, Norman, you just said that both Swire and Mandarin Oriental have been around for 200 years, and yet we're taking down this building after 25 years of its lifetime. Can you speak a little bit to, are there any other things other than the similarities in the climate that brought Swire to Miami? Because it seems like you guys are very local here and feel very much at home. And what are you doing to make sure that the new building is going to have a lifespan that is not just 25 years?
Okay, well, first of all, obviously we are developers, so we obviously at one point have to turn profit on some of these things. But and it's interesting. So the way that we do our development over the course of the last 50 years in Hong Kong and even in Miami is that because we are a highly diversified conglomerate, so our mother company, John Swire and Son Company, owns Swire Pacific, which then in turn owns Swire Shipping. Swire Beverage, we bottle Coca-Cola for everything west of LA in this world. We own Cathay Pacific, the airline, and property is also just one of many businesses that Swire Group owns. So all of our development actually came from turning industry that's no longer relevant in today's world into value-adding real estate. So we turned sugar refinery in Hong Kong into the Taikoo Place. We turned the ship dockyard into, you know, an office complex. So it's Miami, the Brickell Key is no different. At the time when we purchased, it was meant for maritime use. But at the time, you know, so Miami being obviously one of the major trading posts that we have in America. You know, we also have cold storage and other things in the States, but, you know, we just happen to be in Miami here. Is, you know, on the same climate. It just seems like, you know, a really easy transition to just sort of relocate here to being on the same latitude, like I mentioned. So obviously, you know, the Brickell Key plan of being a maritime use didn't pan out. Of course, then we turned it into real estate, you know, a master plan of, you know, just developing the Key over the last 50 years. And that's how we ended up here. And of course, the new building. So when we underwrite our buildings, we usually look at a 50-year investment horizon. And so we have trading properties and we have investment properties. Trading properties being the residential portion. The investment property will be the mixed use, the commercial, the hotel portion of the site. So where these most of our projects, as you see, if you go to Asia, we hold them for 50 years. So this particular one really is just too much unutilized potential. That's why we felt that it's just the best, highest use of it is just to redevelop it.
And it looks like the way that you are redeveloping it is actually looking for a very resilient approach with that idea of the Florida room and going to a passive design that allows people to use indoor and outdoor spaces. Then going back to that concept of the Florida room, traditionally it's an enclosed space. How are you guys reinterpreting that to make sure that people actually really use those spaces?
I think largely through the way that the great room connects to the outdoor balcony. So the great rooms oftentimes open up quite substantially so that actually the great room and the outdoor balcony feel like one room. And I think it's even the same material that comes out from the interior, from the great room to the balconies, which is the same material. And then, you know, if the weather is right, time is right, you open it up, you extend it out, and then you close it. So the relationship of the great room, the family space, the living space, to where those deep balconies are located was very carefully planned. And as you went up the tiers, of course, you had more than one relationship between a sort of a mini Florida room and a mini family room and a larger great room and a larger, so like, you know, as you go up the tiers, they start kind of having different scales as well.
And did you look at throughout a year, at which times can you actually use which space very well? And are there times in the year where you had to, you know, take into account additional measures of design, passive shading, for example, or other ventilation strategies to make those spaces comfortable?
Yes, in the sense that the wind report actually was useful in that regard, where they said that it's interesting that a lot of those balconies are going to have like micro zones within them. And they said, well, you know, actually, like different people are going to probably find their favorite corner in the outdoor balcony. So some person might say, like, you know, I'm going to put my chair right there because I like that, how the breeze works there. And another person might say, you know what, this is uncomfortable, and I'm going to pull back. So we did look at like different scenarios, because the balconies themselves actually were not so homogeneous based on the comfort analysis, which was an interesting finding too, because we didn't realize that. But, you know, I guess they're so deep that they actually allow you to kind of occupy it differently as well.
And is that why you also use that nosing around the perimeter to give it an extra element of shading in those spaces?
There was that, and also the expression as well, both when it's being perceived from the street and also when it's being perceived from elevationally.
I think what Dan also didn't mention is the columns. We brought the columns outboard, so they actually serve as a full height demise that actually shields a lot of the wind. So, but actually, I want to add to what Dan is saying on the Florida room, which is interesting. The courtyard ideas, I want to just touch on this one here. When we were developing this, right, it was actually something that were born out of, a disadvantage, and then KPF was so clever, they were able to sort of pull the unit apart and created this sky courtyard. And our broker fought us tooth and nail saying that you can never sell this unit, nobody will buy them. Guess what, when we launch it, all these units are the first to go. Everybody wants a unit with a courtyard on the sky. They think it's unique, that truly sells the indoor-outdoor living, So, I mean, like I said, right, you never know until you try. You always have to push the boundary a little.
Yeah, that's very interesting. So people really are buying
Correct.
into that idea,
Correct.
and you expect that they'll actually use the space. Have you guys looked into what that means for, like, what does the opening of the doors mean for the comfort indoors? Have you done studies on, taking into account the warm air and humidity coming inside, and what that means for the mechanical system?
Not to that extent. No, we didn't look into what happens when we open it up and that. So no, I don't believe we have analysis of that. We did do a lot of sort of thermal comfort analyses of the balconies themselves. Yeah.
I mean, on a more granular level, I think we did survey the buyers, right? Every buyer that comes, we ask an extensive, we have a lot of data, what buyers really look for. Whether they would use the outdoor space or not, they just love that there's the option of being able to go outdoor. And a lot of our buyers are also snowbirds, seasonal. Some are, private residents, use them as private residents, some are snowbirds. So by the time they come is when Florida gets really nice, and that becomes really a major feature that adds to their lifestyle.
And when we talk about, you mentioned the quality that you guys required of the supply chain for the project in Hong Kong. When we look at these kind of Florida rooms and the indoor-outdoor living with a facade that is operable, was that something where you found that you'd have had to put some extra energy into finding the right quality of the facade supply chain to be able to make these spaces accessible, find a sliding door system that would allow that indoor-outdoor performance to be really smooth?
Yes. I think the challenge in Florida, everybody knows, right, is to be able to obtain a system that has the NOA and the door size, right, you're also quite constrained. So the higher you go, the heavier it is, the more glass, and so on and so forth. It just adds up, right? So the choices are quite limited. So, obviously ES Window is a major player here. So that's, the partner that we first spoke to. So I think, we don't want to, because the quantity, right? This is a 2.6 million square foot project. There's so much sliding glass door that if we start, really try to get them to, let's say, twice the size. And there's also challenge with KPF. We studied early on the modulation of the facade starting to impede the actual interior layout. So in that particular instance, we try to just play safe, get it to as big as possible for the glass panel size, but still within reason, they still work with the interior layout. So that's kind of,
And did you ever get to the point where between you guys and KPF, you had to say, actually, we really would like to achieve this taller span or a larger system, but we really have to amend the design and follow what we can get in terms of what's available, tested in the market? Did that happen?
Yeah. And I mean, in a way, initially we were looking at modules that were pretty large for the sliding systems. Then it was a combination of the NOA, but also us realizing that actually if we only were more strategic with our tracks and with the way that these things kind of fold and disappear, we were actually, once you really want to open up the room, we were realizing that it was working quite well. Like the actual, because these great rooms are so big, in a way. Like even when you try a module that's a little bit larger, you still have quite a few modules because the great rooms are really wide. So in a sense, once you open up those windows, I mean, the effect was the same. However, I think the cost and the consequences on the system were were outweighing it.
But on the tower, I think on the podium, the glass wall, for example, that's in question that we were showing you guys earlier. We have actually amended the height of this glass wall. We went from a 15 meter roughly, like 45 feet or so system, and we had to drop it to about 10 meters or about 30 feet because you know, the only NOA system tested with a single largest span of jumbo glass is only up to 10 meters, just under 10 meters. I think it's 28 feet or so. But obviously, your little shim and you have the top structure. So, like that, for that instance, that we're willing to actually change the design and get the glass system that we want.
That's very interesting because obviously, as you said before, there's a lot of big glass walls that we have done and we've done with you guys together that are much bigger. And theoretically, also here, we have done glass walls where we have gotten a one-time approval to be able to do those rather than going with an NOA. What was the driver for you guys to say, actually, we're okay, we'll change the design? Was it about time? Was it about being able to go to a broader supply chain? What was really driving that decision?
Well, it's actually both, right? So, I mean, we were just talking about this. So what we found is that every time you do, so to get the one-time approval, you need to test things 3 times. Correct me if I'm wrong in the audience. So for every time you do a test, it's about $100,000. So before you get anything installed, plus to actually fabricate the actual material, you have $400,000 in the hole before you get anything. A lot of developers just don't want to take that risk unless you have a huge area of that to use, right? So that's number one. And number two is that the premium. So I think to get this kind of jumbo glass wall, you have 2 suppliers that can do it really well. You have CDEC out of Germany, and you have Nord Glass, Tianjin Nord Glass. With the world that is going with the tariff and everything, what was once affordable just a couple months ago, now it's 25% more expensive. So you also not your supply chain, it's getting more narrow and narrower. So there were more players before, like Sunglass, Precursor, which I believe are it's not available anymore. So it is a challenge, but we're also not afraid of find ways to just bring them over. But then the next challenge becomes finding a facade contractor that knows how to install this and willing to install this and give you the warranty that it needs. So it's challenging, but it's an opportunity as well because we obviously are not afraid and we have nothing but time. This project doesn't open until 2030, so we're slowly chipping away at the problem.
I mean, I would say we also learned from the interior designer on that one, because when we spoke to the interior designer, he was like, 15-meter tall residential lobby. Yeah. Like he was struggling with it because he was like, because, we're looking to achieve some intimacy. I think he was about ready to hang really large things in the space to deal with the heights, right? But like when he looked at the proportion, he was just like, well, actually, this is a residential lobby. It's not a... so actually that was a learning thing for us because when he looked at the 10-meter height, it was like, well, no, this is actually this is quite nice because it's in the end it's a private, it's residential lobby. It's not because it also doesn't have that much depth. So that was a case where actually we realized, they're right. Like, what do you do with the height?
I think that's a very interesting point because for us as engineers, often we think we can make anything possible and we want to have the opportunity to make anything possible and we can detail it all, we can design it all, we'll find the people that can make it. But I think comfort is a very good point. A building is designed for humans, right? For humans to live there and to feel comfortable. I think that's a very interesting perspective to look at for a space like that. That is a relatively small area of the building, but it is the main entrance, and presumably you want people to feel at home.
Yeah, exactly.
So, with that, let's go back up the building a little bit. People feel at home in the lobby. It's a relatively small area of the building. You're still pushing very much the envelope, even if you've made some concessions. Do you see that what you're doing with the sliding door systems, that indoor-outdoor living, it's going to change the landscape of building design and development in Miami?
Yes, I think so. I think if you look at just all the market all the buildings that are done being the last few years, they all have one common thread, right? Indoor-outdoor living, oversized sliding door. Everybody try to get to a 10-foot, 9-foot plus or 10-foot clear sliding panels. Everybody got a nice, facade, balcony that has true curve, but then, or even to not have to have postless balustrade as well. So you can tell the developers are doing it also not just because of aesthetics, right? So it's actually possibly a lot of buyer driven, right? The way we show one buyer that you can have this seamless living experience where the line between indoor and outdoor is blurred, and once they see it, they shop around, right? I mean, they might go to St. Regis, they might go to the Paragon. They will all ask for the same thing. They say, hey, we have buyers that actually ask, how big are my sliding doors? How deep is my balcony? Do I have a post on my balustrade? So these are buyers that's getting more and more educated. They will start asking about these kind of questions. They even ask about drainage slope and how many, whatever. So
I like that. I'm German. I like proper drainage.
Right.
But do people? I mean, I think you see a lot of balconies in Miami, and I never see anybody using them. So I think. How do you get the feeling that this concept of you don't just have a balcony and the doors hopefully always closed just so that it doesn't leak inside? How do you see that development from a facade perspective, engaging people to open up more?
I mean, I feel like over time. Like I said, so it also depends on the tranche of buyers that you're seeing, right? I think if you look at mass market, they probably are just happy to have a balcony. The more discerning buyers, they're really well traveled. They have properties around the world, in Europe, in Asia, in Dubai. I mean, they're used to the good stuff, right? So just, over time, this market just has to evolve and meet that buyer demand organically, whether they want to or not. So I feel that probably we don't mind being the guinea pig a little. We don't mind being a little more adventurous. We want to push the boundary, and hopefully when people see that a lot of this ambition that we're pursuing can get done, and they're willing to match, and hopefully it will elevate the whole market overall. That would eventually help the development of the.
I mean, honestly, we were a little worried when we proposed the courtyard units because we were told it's a bad idea. And, you don't want to propose something over so many floors that's a bad idea. And we were thinking, oh, God, is this a bad idea? Because everybody, like you say, everybody says, nobody uses the balconies, guys. And then, when we heard that they're actually selling well, you got to believe that there's some interest in recovering a kind of outdoor space that's comfortable. That's got to be a drive somehow. So somewhere, somehow, there is an interest in using it. And clearly, when they see a courtyard, I mean, I do think it evokes other ideas of it feels more like a house, or it feels more like an environment that, I know courtyards in Florida. They kind of are interesting, and you do want to go for it. So maybe it's this kind of perception that the outdoor balcony is just not comfortable enough to be there.
And then how you program it, because the way they design it is highly specific. You have a courtyard for dining room, right? You have a courtyard for living room. Maybe not quite a balcony. And another data point that might help is we actually have buyers that will cancel contract if we don't offer the outdoor kitchen. I just want to show you guys the slide. It became such a contentious point with the buyers because they want to use the space. Previously, we had permit issues with, every developer in Miami had issue with getting the outdoor kitchen in, right? You can see in the back of it, and you can see in this slide on the side, right? So we've only always show a sink out there because we can't yet promise that you guys will get a grill. But now that we've actually got proper city approval to put the grill, because we had to put sprinkler in the balcony, So then now everybody is basically expecting and demanding that the outdoor grill is there because they do intend to use these spaces outdoor. It's like, if you don't have it, I will cancel the contract. It has happened 3 times. So I hope this data point help justify, this outdoor living that balcony don't get used, because if it's thoughtfully designed, it's sheltered, they will use it.
I mean, in other words, you're taking a book out to the balcony.
Yeah, I think
they got to do other things.
I think it's very interesting because it is an actual outdoor space, whereas the original concept was more that you have a protected outdoor space, but you really have the access to the elements, which means that your facade, though, has to actually function as your setback internal facade then functions as the barrier. Yeah. So these facades have to perform like any other facade has to perform, even if there's no barrier on the outside. Did you find any? Did you ever run into the problem of a limitation with that, with those facades being fully operable in terms of the sourcing? Was there anything where you felt there's a limit in the supply chain, or was that something that was pretty easy to source?
Yes, it is pretty limited, because the way we like, or with the way we used to sliding doors, the way that the sliding doors detailed, or sometimes we would demand multi-track sliding, the premium goes up substantially. So if you want to say use a Schuko system, which we have, or I forgot what's the other brand, the Italian one, but you want to use something like that, right? They are very high quality, but then they don't have an NOA here.
Mm-hmm.
You don't have, so you're stuck with whatever that's available in this market. And then also you have the 7-year warranty. You have 558 claims. Most of your contract basically is more than a quarter of it is just warranty costs. So there's a lot of these are actually, not the facade industry's fault potentially, but it's because we have there's just so much litigation here in the U.S. that puts a lot of pressure on just making sure that the facade can just perform, just be water resistant, and a lot of the aesthetic consideration goes out the window. So it's unfortunate.
I think it's a very interesting point, because if we think back to the project in Hong Kong that you showed, we're talking very similar conditions. We've got very similar wind loads. We've got a lot of rain as well, and that facade is completely custom designed. Mm-hmm. And that means you can drive or define much more the aesthetic that you get. You can define perhaps even more the performance that you get. But you're saying that wouldn't be an option here in this market just because of the additional expense of the testing.
Just the expense, and also the limitation of subcontractors. So if anybody here is a facade sub that actually willing to take and integrate every other trade together, like come talk to me after this talk. Like for us, like the podium facade, for example, right? It's like the 7 different systems are colliding together. You have stone, you have cast stone, you have metal channels. I have podium glass, I have canopy, I have all these different things. And we need to talk to 7 different subs to do one facade. And then my balustrade on top, my bull nose and my sliding glass door, it's 3 different subs. And even we want everybody to be the same sub, but nobody willing to take the work and just work on it, consolidate and be one single facade. And that becomes a challenge. You're like, no GC can manage this many trades and make sure they don't miss things, right? So that's really the biggest challenge and frustration we are seeing here. And even though, but when you do meet a sub that's willing to take on the work, and they charge an arm and a leg for it, like, why are you charging me $100 for metal extrusions? Because I could easily buy it myself and put it together. So that's also them not wanting to warrant somebody else's work. Mm-hmm. I just wish that the industry is a little more collaborative here, that the sub can just all work together.
But I think that's really an opportunity with a project like that, right, to be an example of creating a quality, not only a quality from a material perspective, but a quality of space that people then engage with, to be an example for new developments. And I think that's where I see a lot of potential even if it is small steps, and perhaps there's small areas of the building where you can test project specific, and the rest of the system is something that is a pre-tested system. I think that's a great opportunity, and hopefully we'll see more of that in the future in Miami.
Absolutely.
I think with that, we'll close it, unless there's any questions from the audience. Doesn't look like it. Looks like everybody's ready for a drink.
2029 to 2030 by batches. Well, if we get into detail, we worked right from the beginning. We decided that Florida rings sideways, so you cannot manage the water. You just gotta shed the water. And I mean, we went through this back and forth whether we have an internal drainage system or not. But then we've decided to modify the bullnose design where we're just simply allowing the water to just drain through under the cavity and exit through whips. Yep. So no internal gutter neither.
Another one over there.
Well, this one here, my mandate is to make sure we deliver something that Swire is proud of, that is worthy of putting our logo and the Mandarin logo on. So right off the bat, it was a set of standards we need to hit. And with the site this special, we just have no choice really but to actually deliver the best, because it's almost, we have a civic duty because it's such an iconic tower right in the middle of the skyline. So we, in the very beginning, almost had a, if you build it, people would come kind of approach, or we actually were thinking, this is always a chicken and egg issue, right? If you go back to the 558 issue, right? Do you have a lot of litigation because buildings are poorly built? That's why a lot of people sue. Or what if we just do it really well, that you don't have to worry about all these 558 issues? So we thought that, okay, we should just do a building that's really, really well done and really high quality that stand the test of time. In every design decision we make, it's about whether it's timeless, whether it will weather well or not. So, and it has served us well. The buyer come and they see it, that it's worth it. So, really, but to answer your question, it's a combination of intuition and really it's just a no plan B approach to just this development. It has to be the best of the best and iconic.
Yeah. So I think the whole idea of how do they manage, how does the owner kind of manage the furniture? How is it kind of they should all be fixed to the ground, fixed to what's fixed, what's not fixed. That's a whole kind of conversation that happened, which is a lot of it has to be fixed down and pinned down. And that's why I think we went through a lot of exercises actually laying them out as living rooms outside, which is where does the table go? Where does this go? Where does the kitchen go? So, I mean, they're actual functional living rooms in some ways. But yeah.
That's a good question. Actually, that was slightly before my time when we finalized the system. But I think I can almost assure you it's definitely going to be an issue of cost. Sometimes when you switch from one system to the next, they just charge you for an exponential increase. So it's not incremental. So when elsewhere in this world, we know that it's an incremental increase, but we have a limited supply, some limited choices here. So we have to work with what we have. So
it's a question. I think it's a good question, though, and it's a question of, do we accept that, right? Do we all not just at some point have to say, actually, there's a lot of systems that work in similar climates, in very similar conditions, and we just have to prove that they do. And I think, and this is how we started a lot of this conversation, is we do that for structural performance anyway, right? And we just prove that it works through testing. Why can't we just prove that a sliding door system wouldn't work either? And both through analysis and testing, that should be easily possible, and that shouldn't be so limited. So I think it's perhaps also a question of demand, and maybe we all need to demand that more and show examples from other places where under the same conditions it works. I think this is a good example of saying we're going one step ahead, and innovation typically works like that, right? One little step at a time. But let's all let's all move that direction and, just test our system, and one little bit at a time we'll get there.
Yeah, I mean, if I'm being even more specific, right? I mean, the most recent battle we are fighting, I found out that all the extrusions here for mullions are 2-coat PVF2. And from where we're from, it's 4-coat. Since the day I learned about facade, we've been using 4-coat PVF2. And I told the supplier, they're like, that's crazy, nobody do that here. And I said, okay, how much is it to go from 2-coat to 3-coat? And he said, double. And then how much is it to go from 3-coat to 4-coat? Another double. But then I called up my guys in Hong Kong, how much is it to go from 2-coat to 4-coat? No price change. It's a standard. I don't offer 2-coat. That's straight up what they tell me. So, like you can tell, right? This is the battles we're fighting, on something as simple as just coating on your extrusions. So,
but then
we have to.
We want something that lasts very long in a highly erosive environment, right? So if we want to make sure that buildings don't just last 25 years, we better have a proper coating on the mullions.
Correct. Absolutely. We need them indestructible.
Okay, I think we're going to close it out with that. Thank you guys for sticking with us for so long.
Well, thank you, Lisa, Norman, and Daniel. Such an amazing discussion panel. So with that, it concludes our event for the day. And thank you so much, everybody, for coming out here. And thank you for having me as your host. If you need AIA credits or certificate of completion, you can go to the registration desk. They'll be happy to hand it over to you. And thank you again, Zach, for putting this amazing event together. And we hope that we have another one next year. So thank you again. And Susan will take over.
Thank you. Thank you, everyone, for coming today. This is my hometown. So yay, Miami. I grew up on the beach. And great to be here with Zach. Thank you. We'll see you again next time. And I wanted to thank Javat especially for emceeing today. And you did a great job. Thank you. And thank you to all the speakers. Please come up to the stage if you haven't come for a photo. We'll see you again soon. Thank you so much.